Hey, chums of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to study all your entrance exam question papers, this one and many more similar type of. Students, for a better approach to your studies and preparation, you must download our app. The link is available in the description box. Today, in this particular video, we'll be solving TS EAMCET Engineering 13 May 2023 shift 1 paper. You're having different sections in physics, chemistry, and mathematics. In this particular video, we'll be solving only the mathematical part. So let's go with that. Our very best of luck. Here we start with question number 1. It says if the function f from real numbers to real numbers is defined by fx is equal to 2x minus 3, if x is less than minus 2, it is x squared minus 1 if x lies between minus 2 and 2. And it is 3x plus 2 if x is greater than 2, right? Then f is an injection but not surjection, surjection but not injection, a bijection, neither injection nor surjection. Which type of function is this? Fine. So see, the breaking point here are the two ones, like minus 2 and 2. So let's see for both how the function behaves for both of them. For x is equal to 2, you have f of 2 is equal to 2 square minus 1, which is equal to 3. For x is equal to minus 2, f of minus 2 is equal to minus 2 square minus 1, which is again 3, right? So see, for that means f when x is equal to 2, f2 is equal to f of minus 2. That means f is not injective. That means it is injective. That means it is not 1 to 1. Now, for x less than minus 2, for x less than minus 2, you have the function as 2x minus 3, which is, of course, less than minus 7. And for x lying between minus 2 and 2, this can be written as 0 is less than equal to x square is less than equal to 4, because when I'm squaring it. So here you will have a minus 1 less than equal to x square minus 1 less than equal to 3. And for x is equal to minus 2. Wait, it was greater than minus 2. Wait. For x greater than, for x greater than minus 2. Minus 2. X greater than, sorry, I'll rewrite this thing. For x greater than 2, the function was 3x plus 2. This is greater than 8. Therefore, fx belongs to minus infinity, minus 7, union, minus 1, 2, 3, union, 8, infinity. Therefore, range of the function is the subset of codomain of f. Hence, f is not onto and not surjective. Therefore, it is neither injection nor surjection. Okay, so that makes option D to be the correct answer. Hope you understood that. Next is question number 2. The domain of the real valued function fx is equal to this is here this denotes the greatest integer function. I hope you already know this thing. So the domain of this function is what? Let's write down the function. It is fx is equal to root of log 10 x upon x minus 2 whole root under the root divided by whole root greatest integer function of x square minus 5 into greatest integer function x plus 6. Here the function is defined when, of course, this will be greater than 0. Function will be defined when this is greater than 0. Of course, not equal to, okay? Equal to can't come over here. So let's factorize it. Splitting the middle term, you will get the two factors as x minus 2, x minus 3 greater than equal to 0. So that means greatest integer function of x belongs to minus infinity to 2 union 3 to infinity. So that means x belongs to minus infinity to 2 union. See, you will take the 4 over here because I'm removing the greatest integer sign. So 4 will come over here, comma, infinity. And log 10, this, it should be greater than equal to 0, of course, because it is lying in the denominator, and the denominator, of course, it is under the root. So it can be greater than equal to 0 only. So let's pick up that one. So I have picked up the numerator now. Now it will be x upon x minus 2. It should be greater than equal to 1, which gives you 2 upon x minus 2 should be greater than equal to 0, right? Or x minus 2 should be greater than equal to 0. Gives you x should be greater than equal to 0. Or x will belong to 2 to infinity. Okay, this is closed. Sorry, it was x over here. So x will belong to 2 infinity. So that means domain of fx will be equal, domain of fx will be 4 infinity, right? So now let's check what do you find needed to find out the domain of this function, and it is equal to option D. Hope you understood this. Next is question number 3. The range of the real valued function fx is equal to this is equal to this. Question number 3, the range of the real valued function fx is equal to 1 upon x minus mod of x is which of these options? See, for sure, you cannot have x is never equal to mod of x because then the denominator will be equal to 0. Therefore, the mod of x, because it's a positive value, it will always be greater than x. And that means x minus mod of x will be less than 0, which makes 1 upon x minus mod of x less than equal to 0. That means fx will always be less than equal to 0, which makes the range of fx will belong to minus infinity to 0. That's it. You have option B as your answer. Hope you got that. Let's move to the next question. Question number 4. If A is the matrix given by this and B is the matrix given by this, then you have to find out A square. That means simply you have to find out A square. You'll be multiplying, but the answer is not in the matrix form. Of course, you need to solve and check which of these options will be the correct answer. So, of course, A square will be equal to 1 to minus 1, minus 1, 0, 2, 1, 2, 0. 1, 2, minus 1, minus 1, 0, 2, 1, 2, and 0. So let's multiply that. You will get first row, first column. It will be 1, minus 2, minus 1. And then you have 2, 0, minus 2, minus 1, plus 4, 0, minus 1, 0, 2, minus 2, 0, 4, 1, 0, 0, 1, minus 2, 1, minus 2, 0, and 2, 0, 0, minus 1, 4. Okay, which will give you the answer as minus 2, 0, 3, 1, minus 1, 2, 2, 1, 3. All right, so this is the answer. And let's pick up the first one, A minus B. If I say A minus B, that means 1, 2, minus 1, minus 1, 0, 2, 1, 2, 0, minus 3, minus 2, 4, 2, 2, minus 1, minus 2, 0, 3, So let's subtract them. You will have 4, 4, minus 5, minus 3, minus 2, 4, no, 3, sorry. And this will be 3, 2, minus 3. Okay, these are not equal, so this is not the answer. Let's check with the second option that was equal to b minus a. You will check. Similar way, you will check. You will not get the b minus a as well as the answer. Let's check with the a plus b. So a is equal to 1, 2, minus 1, minus 1, 0, 2, 1, 2, 0, plus minus 3, minus 2, 4, 2, 2, minus 1, minus 2, 0, and 3. You have to add them, and you will get the answer as minus 2, 0, 3, and 1, 2, and 1. Then is minus 1, 2, and 3, which is, of course, we solved a square. Just check. That is equal to a square exactly. So that's it. We got our answer. Option C stands to be the correct answer. Hope you understood this. Next is question number 5. So simple as that. You are given two determinants and you have to add them and then find out what is the answer. So let's add them. The first one, 3, 5, 3, 5, 2, 5, 2, 3. This is equal to, the determinant will be 2 into 5 into 3, 15, minus 4, minus 3, 9, minus 10, plus 5, then 6, minus 25. Correct? This will be equal to 2 into 11, that is equal to 22, minus this plus 3, and this is 19. 19 fives are 19 fives are 95, right? So this is minus 95. So 95 minus 25 will be equal to minus of 70, right? The second one, but second one, see, it is having very large numbers, 111, 7, 11, and 13. And the next one, 49, 121, and 169. These are very large numbers. So let's apply some transformations. Let's say C2, let's transform C2 to C2 minus C1 and C3 to C3 minus C1. So here you will have this will be equal to 1, 0, 0, 7, 49, 4, 6, 72, and 120. Now let's find out the determinants. Very easy now. 1 into 4 into 120 minus 72 into 6. This is equal to 480 minus 432, which is equal to 48. All right. So according to question, you have to find the sum of these according to the question. To find is equal to determinant first, which was minus 70, plus determinant second, which is plus 48. That gives you minus 22 as your answer. So option D is the correct answer. Hope you understood that. Next is question number 6. If A is given by this matrix and determinant of A is 119, what is adjoint of A? Let's write down the matrix. You are given A matrix, determinant is 190. Also, A matrix is K5, 2, 2 minus K5, 5, 2, and minus K. So that means determinant of this K minus 2 minus K 5, 5, 2 minus K is equal to 190. Let's find out the determinant. It will be K into K square minus 1 minus 5 minus 2K minus 25 plus 2, 4 plus 5K. So that makes it K into K cube minus 10K plus 10K plus 125 plus 8 plus 10K. These two will cancel and you have a K cube plus 10k plus 133 is equal to 190, right? That makes k cube plus 10k, and 190 minus this will be equal to 7 and 5. So 57, right? Okay, so this is k cube plus 10k minus 57 is equal to 0. So one of the factors of this will be equal to k minus 3. Let's check with this. If I'm putting k is equal to 3, it will be 3 cube minus 3 into 10 minus 57, which is 27, plus 30 minus 57, which is equal to 0. So k minus 3 is one of the root. If I'm dividing this with k minus 3, you will get the remainder as, quotient as k cube plus 10k minus 57. So let's multiply. Here was k. Let's multiply it with k square. You have k cube minus 3k square minus plus. So 3k square minus plus 10k plus 3k square minus 9k minus plus cancel 19k minus 57 plus 19. So 19k minus 57 minus plus cancel 0. So the second two factors are k minus 3 into k square plus 3k plus 19 is equal to 0. Okay, right. So from here you get k is equal to 3. One of these factors, but see, of course, this is the positive one, and 3k and 9. Let's say k is equal to 3. So adjoint of A is equal to, that is equal to transpose of cofactor matrix of A. Cofactor matrix of A. And when you will find out the transpose of it, see, you have to find out the adjoint of A. So let's go for that. Question number 6. If A is given by this matrix and determinant of A is 190, you have to find out adjoint of A. To find out the adjoint of A, first of all, need to find out what is the A matrix. And for that, let's find out what is the value for K. Let's go for that. According to the question, the determinant of A, which is K5, 2, 2 minus K5, 5, 2 minus K, this determinant is equal to 190. So let's find out k into k square minus 10 minus 5, 4 plus 5k. Yeah. Sorry, this is not, yeah. And minus 2k. Sorry. Minus 2k and minus 25 plus 2, 4 minus plus 5k is equal to 190. So this will be equal to k cube minus 10k plus 10k plus 125 plus 8 plus 10k is equal to 190. So you will have k cube plus 10k minus 57 is equal to 0. Now you will see one of the factors of it is k minus 3. See, when I'm putting k is equal to 3, this expression will be equal to 3 square q plus 10 into 3 minus 57, and you will see 27 plus 30 minus 57, which is equal to 0. So that means k minus 3 is one of the roots. So let's find out the second root. So k minus 3, I'm dividing. This will be k cube plus 10k minus 57, k square, k cube minus 3k square minus plus, you have 3k square plus 10k plus 3k. This will be 3k square minus 9k minus plus, this will cancel, and you have 19k minus 57. Here will be plus 19, 19k minus 57. This will be So the two factors will be k minus 3 into k square plus 3k plus 19 is equal to 0. That makes k is equal to 3 as one of the root. So let's make the 8 matrix now will be equal to 3, 5, 2. Then you have 2 minus 3 and 5. 5, 2 minus 3. Fine, this is the A matrix. And what is adjoint of A? This is nothing but transpose of its cofactor matrix. To find the cofactors, you need C1, 1, 1, 2, 1, 3. First row, first column, first row, second column, first row, third column. And then you need to have a C2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. So first row, first column I'm leaving. You have 9 minus 10. That is equal to minus 1. First row, second column, you have minus 6, minus 25, right? That makes minus 30, 31. Then first row, third column. First row, third column I'm leaving. This is equal to 4 plus 15. That is equal to 19. Okay. Then second row, first column, you have minus 15 minus 4, which is minus 19. Second row, second column, you have minus 9 and minus 10, which is again minus 19. Second row, third column, you have 6 minus 25, which is equal to minus 19. Third row, first column, 25 plus 6, 31. Third row, second column, 15 minus 4, 11. And third row, third column, you have minus 9, minus 10, which is minus 19. So let's make the cofactor matrix well, first of all. Cofactor matrix. This will be multiplied by minus 1 raised to power 1 plus 1, which is 2. This will be minus 1 raised to power 1 plus 2, which is 3. So this will be positive, and this will also be positive. Yeah, this will be, that's it. And this is minus 1 raised to power 1 plus 3, that is equal to 4. This will be minus 1 raised to power 2 plus 1, which is 3. Here will be minus 1 raised to power 2 plus 2, which is 4. Minus 1 raised to power 2 plus 3, which is 5. Minus 1 raised to power 4. Minus 1 raised to power 5. Minus 1 raised to power 6. So that will, of course, change the sign over here, not over here, over here. And yeah, it will be changed at this place also, and that's it. So let's make the cofactor matrix now. It will be given by minus 1, 31, 19. Then you have 19 minus 19 and 19. And then you have 31 minus 11 and minus 19. Now let's make out the adjoint of A. I'm finding the transpose of it. So adjoint of A will be given by minus 1, 31, 19, 19 minus 19, 19 and 31 minus 11 and minus 19. So this is the answer to the question, right? Let's check with the options which one is the correct one. You will find out option A is the correct one. Hope you understood that. Let's move to the next question. Question number 7. The unique solution of the simultaneous linear equations this, and this is x is equal to alpha, y is equal to beta, z is equal to 3. Then what is the value for k? Now you're given the three equations. Let's write them. Let's write down equations first. First of all, it is 3x minus 2y plus z is equal to 5k. 2x plus 3y minus 2z is equal to minus 5k. X plus 4y plus 3z is equal to k. So these are the linear equations, and see, you are given that they have a unique solution. That means their determinant is not equal to 0, right? Which means x will be equal to delta 1 upon delta, y will be equal to this, and z will be equal to delta 3 upon delta. Now let's find out the first determinant, which is delta. This is 3 minus 2, 1, 2, 3 minus 2, 1, 4, and 3. Let's find out. So the determinant will be given by 3 into 9 plus 8 minus plus 2. It will be 6 plus 2 plus 1, 8 minus 3. This is equal to 17 3s are 51 plus 16 plus 5, which is equal to 72. Of course, this is not equal to 0. So, all right, I have to just find out the value of k, but I'm only given the z. So let's say here the delta 3 will be equal to 3 minus 2, 5k, 2, 3 minus 5k, 1, 4k. Now let's again find out the determinant. This is 3 into 3k plus 20k minus plus 2k plus 5k plus 5k, 8 minus 3. That gives you 23k plus this 69k plus 14k, and this is 25k, which is equal to 108k. And you are given in the question that z is equal to 3. That means this is equal to 3, and 108k upon 72 is equal to 3. That gives you k is equal to, this cancels at 36. So k is equal to 2. This is the answer to the question. You need to find out the value of k, and that is equal to 2. Option B is the correct answer. Hope you understood that. Let's move to the next question. Question number 8. The value of this plus this is a negative real number k. Then what is the value for k? Okay, I'll pick up the first one first. Minus 5 minus 12 iota whole under the root. This is equal to plus minus root of root minus 5 square plus minus 12 square plus minus 5 under the root. This is under the root, and then this whole thing is under the root upon 2 minus iota. Question number 8. If the value of this plus this is a negative real number k, then what is the value for k? Pick up the first term of it, minus 5 minus 12 iota whole under the root. This is given by plus minus of root of minus 5 square plus minus 12 square. This under the root, whole under the root of plus minus 5 upon 2 minus iota into the same thing, minus root of minus 5 square plus minus 12 square minus of minus 5. This was under the root, and this is whole under the root divided by 2, right? So when you will solve this, it will be equal to root of 25 plus 144. This is 169 minus 5. This was whole under the root minus iota. Same thing, 169 minus plus upon 2, whole under the root. So next, this is equal to 13 minus 5, which is equal to 8. 8 divided by 2, that is equal to root of 4, minus iota root of this will be 13 plus 5, which is 18. 18 divided by 2 will give you 9. So this is equal to plus minus. Here was the plus minus. So plus minus 2 minus 3 iota. Similarly, you will calculate for the second term of the given question, which was, this was, let's say, number 1. And let's pick up the second term, which is root 7 plus 24 iota. So root, it was 7 plus 24 iota. This is equal to root of 7 square plus 24 square. Let's rewrite. 7 square plus 24 square, whole under the root. This is again under the root, minus plus 7 upon 2. Then plus iota, here was plus minus, plus iota, the same thing, root of 7 square plus 24 square, then minus 7 root of 2. All right, brackets close. So that is plus minus 7 square 49, and plus 24 square. This will be the wait, 24 square was, I just forgot, 9, and 576. 576 plus 49, that's 5 2. So this is equal to root of 625 plus 7 upon 2, whole under the root, plus iota root of 625 plus 7 minus 7, sorry, whole divided by 2. This is 25 plus 7. 25 plus 7 gives you 32. 32 divided by 2. This is root of 16 plus iota. 25 minus 7. This will be 18. 18 divided by 2 is root of 9. So this is equal to plus minus 4 plus 3 iota. Now, let's say this is 2. Adding. This is what you need to find out. Adding 1 and 2. You have root of minus 5 minus 12 iota plus 7 plus 24 iota is equal to, that was plus minus, it was 2 minus 3 iota plus minus, it is 4 plus 3 iota. Now let's get back to our question once. It's a negative real number k. The sum of these two is a negative real number k. So these two are negative real number. So I'll pick up the negative parts of it. You will have minus 2 minus 3 iota minus 4 plus 3 iota is equal to k. Minus 2 plus 3 iota minus 4 minus 3 iota is equal to k. Minus 6, they will cancel, is equal to k. So k comes out to be minus 6. That's it. You got your option C as the answer. Hope you understood this. Let's move to the next question. Question number 9, let z be equal to x plus iota y. We have point on the Argand plane. If the amplitude of this is pi by 2, then what is the locus of the z? That is the complex number. We are given in the question that amplitude z minus 3 upon z plus 2 iota is equal to pi by 2. Let's put down the z. Z was equal to x plus iota y. So this will be amplitude x plus iota y. So this will be x minus 3 plus iota y. I'm separating the real and the imaginary part over here. Divided by x plus iota into y plus 2. Right? that is equal to pi by 2. Now let's rationalize this. So you have amplitude x minus 3 plus iota y whole divided by x plus iota y plus 2, x minus iota y plus 2 whole divided by x minus iota y plus 2. This is equal to pi by 2. Now let's open it up. You will have the amplitude of, this will be x into x minus 3 plus y into y plus 2 plus iota xy minus x minus 3 into y plus 2 whole divided by x square plus y plus 2 whole square, that's equal to pi by 2. Now in the question you are given that the amplitude, you are given amplitude of z minus 3 upon z plus 2 iota is equal to pi by 2. Therefore, this means z is this whole z minus 3 upon 2 plus, sorry, z plus 2 iota is purely imaginary. That means the real part is equal to 0. And what is the real part? Let's see. This is this thing. This will form the real part. Correct? Let's go. You have x into x minus 3, y into y plus 2. Denominators will it will cross multiplied and this will be 0. Okay. So now let's open up. You have x square minus 3x, y square plus 2. Y is equal to 0, which makes x square plus y square minus 3x plus 2y is equal to 0, which is, of course, the equation of the circle with, okay, yeah, this is the equation of the circle. Let's see. So it's a circle, it's a straight line, semicircle arc not containing the origin, semicircular arc containing the origin. So see, the origin has been discussed over here. We have to check whether it passes through the origin, yes or no. Origin has the coordinates as 0 and 0. So of course it passes through the origin. 0 square, minus 3 into 0 plus 2 into 0. This will be 0. So it passes through the origin also. It contains the origin, right? That makes option D as the answer. Okay. Hope you understood that. Next is question number 10. If a point P denotes a complex number Z is equal to x plus iota y in the eigenplane, and if this is purely real, then the locus of the P is equal to. Let's write down your given the complex number as Z minus 2 plus iota upon Z plus 1 minus 2 iota. You're given z is equal to x plus 2y. So let's fill in that and separating the real and the imaginary part. So this will be x minus 2 plus iota y minus 1 whole divided by x plus 1 plus iota y minus 2. Okay. And now rationalize it also. So you will have x plus 1 minus iota y minus 2 whole divided by x plus 1 minus iota y minus 2. So this will be x minus 2 into x plus 1 plus y minus 1 into y minus 2. Yeah. And this whole thing plus I'm separating the imaginary part now. Iota x plus 1 y minus 1 x minus 2 into y minus 2. This whole thing is divided by x plus 1 square y minus 2 square. Okay. Now in the question it is given that it is purely real. That means imaginary part is 0. If it's purely real, then according to the question, the imaginary part, I'm ignoring the denominator because ultimately it will be cross multiplied and become 0. So this will be x plus 1 y minus 1 minus x minus 2 y minus 2. This is equal to 0. Yeah. So here either of these things. See, let's open it up. One thing is for sure on the question. Wait. Okay. Let's open it up. You have a xy minus x plus y minus 1 minus xy. This will be plus 2x plus 2y minus 4 is equal to 0. Xy, they will cancel out each other, and you will have x plus 3y minus 5 is equal to 0. So let's check with the options now, which is the correct one. The line this x plus 3y minus 5. Yes, we got this line, but excluding the point minus 1 and 2. So we have to check for these points as well, minus 1 and 2. See, x cannot be minus 1 and 2. Why is that? Because if I'm putting, this is the real part of the complex number. See over here, x minus 2, x plus 1, plus y minus 1 and y minus 2. So from here, if I put x is equal to minus 1, then this whole thing will be 0, right? And this thing y cannot be equal to, so x cannot be equal to minus 1 and y cannot be equal to 2, because then this real part will be 0. But in the question, it is said that it is purely real, so real part is not equal to 0. From here, you cannot have x is equal to minus 1 and y is equal to 2. So that means this is the line. See, this is the equation of the line, and excluding the point minus 1 comma 2. Okay, so that makes option A to be the correct answer. Hope you understood this. Let's move to the next question. Question number 11. If iota is the root of this equation, x squared plus 1 is equal to 0, then what is the value for this expression equal to? Okay, let's start. Before starting with the question, let's see. You know one thing that 1 omega and omega square, they are the cube roots of unity. So you have omega is equal to minus 1 plus minus, I have the two things, plus iota root 3 upon 2. And omega square is minus 1 minus iota root 3 upon 2. All right. So next, one more thing you have is 1 plus omega square is equal to 0 and omega cube is equal to 1. All right. So you have from here, you have from this one, I can have minus 2 omega is equal to minus 1. Question number 11. If iota is the root of the equation x square plus 1 is equal to 0, then you have to find the value for this expression. Before starting with the question, this thing reminds me of something. I'm just going to discuss that. First of all, you know that 1 omega and omega square, they are the cube roots of unity, right? From here, you have the value of omega as minus 1 plus root 3 iota upon 2, and omega square is given by minus 1 minus root 3 iota upon 2. One more thing, 1 plus omega square is equal to 0 and omega cube is equal to 1. So from here, if I cross multiply the 2 and multiply both the sides by minus, I will get 1 minus root 3 iota, and here will be minus 2 omega square is equal to 1 plus root 3 iota. Now let's get back to our expression. To find was 1 plus root 3 iota raised to power 2023 plus 1 minus root 3 iota raised to power 2023. So this is equal to, see, this is equal to minus 2 omega square raised to power 2023, and this is equal to minus 2 omega raised to power 2023. So I'm taking the minus 2 raised to power 2023 common. Inside, I'll be left with the omega raised to power 4046 plus omega raised to power 2023. All right. So, yeah. Now, one thing, this will be equal to what? Wait, I just want to discuss one thing. Omega raised to power 3 is equal to 1. So that means omega raised to power 3 into n is also equal to 1. And let's divide this 4046 with 3. You will have 1, 3, 4, and this. So this is at 8. So the remainder over here is 2. So this can be written as omega square. And the second one, which is 2023, if I'm dividing it with 3, you have 6, 7, and 4. So the remainder is 1. So this is equal to omega itself, right? I hope you understood like what I have done over here. And we also have discussed one formula, that is 1 plus omega square is equal to 0, which makes omega plus omega square is equal to minus 1. All right. So this is equal to, this is an odd number. This can be written as minus 1 raised to power 2023 into 2 raised to power 2023 into minus 1. And minus 1 raised to power any odd number is equal to minus 1. So minus 1 into 2 raised to power 2023 will be equal to 2 raised to power 2023. So this is the answer to the question, and you have option B as your answer. Hope you understood that. Let's move to the next question, number 12. One of the values of this expression is this. This part is not there. So one of the values for root 3 minus iota raised to power 1 by 6 is which of these options? Let's say this is equal to z. Let z is equal to root 3 minus iota. So what will be the modulus of it? This is given by this. That's equal to root 3 square, which is equal to 3. Minus minus plus. So this is, sorry, this is plus 1. That is equal to 2. So you got the modulus of it, and the theta, which is the argument of the complex number, it is minus tangent inverse 1 by root 3. That will be equal to minus pi by 6. And now this complex number root 3 minus iota will be given by 2 cis minus pi by 6. I have to get rid of this minus. So this can be written as a 2 cis 2n pi minus pi by 6. And raised to the power 1 by 6 on both the sides. This will be equal to 2 raised to power 1 by 6 cis 2n pi by 6 minus pi by 36, where n is equal to 0, 1, 2, 3, 4, and 5. So that means this is equal to 2 raised to power 1 by 6, say, cis, that will be equal to, I'm taking the LCM, all right? So this will be 12n minus 1 upon 36 pi. So now what do you have to find out? The options. You don't have anything in the question in the options. So when you will check out all the possible values for n, that is 0, 1, 2, 3, 4, 5, you will find out that for n is equal to 5, root 3 minus iota raised to power 1 by 6 was equal to 2 raised to power 1 by 6 cis. I'm putting n is equal to 5. So this will be 60 minus 1, that is equal to 59 upon 36 pi. Okay, that makes option C to be the correct answer. Hope you understood that. Let's move to the next question. Question number 13. X squared plus 3x minus 2k k is equal to 0, and this equation have non-zero common root, then the positive root of this equation will be given by. So let's say alpha and beta are the roots for the equation x squared plus 3x minus 2k is equal to 0. And alpha and gamma are the roots for the equation x squared minus 2x minus 7k is equal to 0. Where alpha is the common root between them and this is not equal to 0. Right? Now, according to the question, you know, the sum of the roots is given by minus b upon a, which is equal to minus 3. And product of the roots is given by c upon a, which is minus 2k. Okay. Also from here, the sum of the roots, that's alpha plus gamma, is equal to minus b upon a, which is equal to, that is, 2. And alpha into gamma, that is equal to c upon a, which is equal to minus 7k. So you got these, yeah, we got these things. Now let's solve them. Let's say this is equation 1. This is equation 2. This is 3 and 4. Solving 1 and 2. 1 and 2, you have beta minus gamma will be equal to -5, and solving 3 and 4, you will have beta upon gamma is equal to 2 by 7, which gives you beta is equal to 2 by 7 gamma. So I'll fill in this equation, beta is equal to 2 by 7 gamma. So 2 by 7 gamma, I'm going to fill in this equation. 2 by 7 gamma is equal to -5. That is -5 upon 7 gamma is equal to -5. -5 will cancel, and you will have gamma is equal to 7. So gamma, now you're given that we have seen that the gamma is the root of this equation. Gamma is root of x square minus 2x minus 7k is equal to 0. So 7 square minus 2 into 7 minus 7k is equal to 0. 49 minus 14 minus 7k is equal to 0, which gives you 35. So that is k will be equal to 5. Now let's get back to our equation. Question number 13. X squared minus 3x minus 2k is equal to 0, and x squared minus 2x minus 7k is equal to 0 have a non-zero common root. Then the positive root of this equation is, okay, so you have the two equations. First is x squared 3x minus 2k is equal to 0. Let alpha and beta be the roots of this equation. And you have the second equation as x squared minus 2x minus 7k is equal to 0. Let alpha and gamma be the roots, right? You have a common root non-zero. So here you have the common root as alpha, and you have alpha as non-zero one. This is the common root. So from here, you know the sum of the roots is equal to minus b upon a. That is minus coefficient of x upon the coefficient of x squared. So this is equal to -3. And from here, you have x alpha plus gamma. Similarly, this is equal to 2. Let's say this is equation 1 and 2. Here you have the product of the roots as c upon a, which is -2k upon 1. Here the product of the roots is equal to -7. Okay, let's say this is equation 3 and this is equation 4, right? Now let's, from 1 and 2, subtracting 1 from 2. Subtracting 2 from 1. Right. Subtracting 2 from 1, you will have a beta minus gamma is equal to -5. And then I'll solve 3 and 4. You will have a beta upon gamma is equal to 2 by 7, which gives you beta is equal to 2 by 7 gamma. So I'll put this one in this equation. You will have a 2 by 7 gamma minus gamma is equal to this, minus 5 by 7 gamma is equal to -5, which gives you gamma is equal to 7. Okay. Now gamma is the root of x squared minus 2x minus 7k is equal to 0. That gives you 7 square minus 2 into 7 minus 7k is equal to 0. 49 minus 14 minus is equal to 7k, which gives you k is equal to 5. Now the required equation, this becomes, so equation becomes 5x squared plus 7x minus 6 is equal to 0. Let's solve it. You want two such numbers. The sum of the numbers should be plus 7, and the product should be minus 30. And you will solve it. I'll be applying the quadratic formula for the same. So after applying the quadratic formula, which is given by x is equal to minus b plus minus b square minus 4ac upon 2a, you'll get the two values of x as 3 by 5 and minus 2. So from here, the positive root is this 3 by 5, and this is the answer. That means 3 by 5 is the answer to the question. Option D stands to be the correct option. Hope you understood this. Next is question number 14. We have to find the values of this do not lie in which of these intervals. Yeah, let's say this is equal to y is equal to x squared minus 2x plus 1 upon x squared plus x minus 1. So, okay, let's open it up. Y x squared plus xy minus y is equal to x squared minus 2x plus 1. This gives me, I'm taking x squared common, y minus 1 plus x, you have y plus 2 minus y minus 1, or you can have minus y plus 1 is equal to 0. Now, the value does not lie in the given interval. Value does not lie in the given interval if discriminant is less than 0. And you know discriminant is given by b square minus 4ac, right? So this becomes b square, which is y plus 2 whole square minus minus plus 4 this into this. This is less than 0, correct? Y square plus 4 plus 4y plus 4y square, and this is y square minus 1, so minus 4 isn't equal to 0. You have 5y square plus 4y less than 0. I'm taking y common. 5 plus 5y plus 4 is less than 0. So it will lie between minus 4 by 5 to 0. So that means y does not lie between, y doesn't lie between this. Okay. And that makes option A to be the correct answer. Hope you understood this. Next is question number 15. Alpha, beta, gamma are the roots of this equation. Then what is the value for this expression? Okay, you are given the equation x cube minus 3x squared plus 3x plus 1 is equal to 0. Transforming the equation whose roots are this alpha, beta, gamma. Transforming the equation whose roots are, I'll be taking alpha square, beta square, and gamma square. For that, I'll be replacing here the x by x to x raised to power 1 by 2. For this, replacing x with x raised to power 1 by 2. Okay, now this equation will become x raised to power 3 by 2. If I'm taking replacing x by x raised to power 1 by 2, this will be 3x raised to power 3 by 2 minus 3x plus 3x raised to power 1 by 2 plus 1 is equal to 0. Or x raised to power 3 by 2 plus 3 into x raised to power 1 by 2. This whole square will be there. This will be equal to 3x minus 1 whole square. Question number 15. If alpha, beta, gamma are the roots of this equation, then what is the value for alpha square, beta square, plus like this whole thing? What is the value for that? You're given the equation as x cube minus 3x square plus 3x plus 1 is equal to 0. Now, transforming the equation to the one whose roots are alpha square, beta square, and gamma square, because we need that over here. So for that, you have to do for this replacing x by x raised to power 1 by 2. So you will have x raised to power 3 by 2 minus 3x plus 3x raised to power 1 by 2 plus 1 is equal to 0. I'll do 3 raised to power x plus x raised to power 3 by 2 plus 3 into x raised to power 1 by 2 is equal to 3x plus 1. Let's do squaring on both the sides. Minus 1, not plus 1. Yeah, right over here, minus 1. So this will be x cube plus, I'm opening the squares, x cube plus 9x plus 6x square is equal to 9x square plus 1 minus 6x, which will be x cube minus 3x square plus 15x minus 1 is equal to 0. Then sum of product of the roots, you know that formula, sum of product of roots taken two at a time will be alpha square, beta square, gamma square plus gamma square, alpha square. This will be equal to C upon A, which is equal to 15 upon 1, that is equal to 15. So the answer to the given question is option B. Hope you understood this. Next is question number 16. Alpha, beta, gamma are the roots for this equation. Then alpha is less than beta is less than gamma, and the value for alpha plus 2 beta plus 3 gamma is equal to. You're given the expression x cube plus 4x square minus 9x minus 36 is equal to 0. So the factors of 36 are plus minus 1, 2, 3, 4, 6, 9, 12, 18, and 36. So if you see this, from all of them, you see x is equal to 3. It is satisfying the given equation. Satisfying given equation. So one of the factors is x minus 3 for this equation. And let's find out another factor. You had x cube plus 4x square minus 9x minus 36, x minus 3 as one of the factors. Here will be x square. You have x cube minus 3x square minus plus you have 7x square minus 9x plus minus 36. Next will be 7x. So this will be 7x square minus 21x minus plus cancel. And you have 12x minus 36. So here will be plus 12, 12x minus 36 minus plus 0. So the two factors will be x minus 3 and x square plus 7x plus 12 is equal to 0. X minus 3, let's spread the middle term. You will have x square plus 4x plus 3x plus 12 is equal to 0. And the two factors apart from x minus 3 will be x plus 3 into x plus 4 is equal to 0. So x will be equal to 3 minus 3 and 4. The question you are given that alpha is less than beta is less than gamma. So that makes given as alpha is less than beta is less than gamma. That makes alpha is equal to, here was minus 4. Alpha is equal to minus 4, beta is equal to minus 3, and gamma is equal to 3. To find the question was alpha plus 2 beta plus 3 gamma is equal to minus 4 minus 6 plus 9. That makes minus 1 as the answer to the question. So that is option C is the correct answer. Hope you understood this. Next is question number 17. If the sum of the two particular roots of this equation is equal to the sum of the remaining two roots, then the sum of the cube of all the roots of this equation is. We are given the equation x raised to power 4 minus 4x cube minus 7x square plus 22x plus 24 is equal to 0. Let's say A, B, C, D be the roots of the given equation, such that you are given the sum of two particular roots is equal to sum of another two roots, such that A plus B is equal to C plus D. It's given. Okay. Also, know one thing, sum of the roots is equal to minus b upon e. So that gives you alpha plus beta plus, a plus b plus c plus d is equal to minus of minus 4 upon 1, which is equal to 1. Okay. That gives you c. If a plus b is equal to c plus d, that means surely they each are equal to 2. That is half of 4, right? So let's say this is equation 1 and then equation 2. Next is sum of product of the roots. Sum of product of the roots is given by that is c upon a, which is equal to minus 7 upon 1, that is equal to minus 7, right? So you have a b plus bc, ab plus ac, ad, bc, bd, cd. This is equal to minus 7. So you have AB plus A, C plus D, B, C plus D plus CD is equal to minus 7, or AB plus CD plus, I'm taking the common ones, is equal to minus 7. AB plus CD plus, that's equal to 2 into 2, 4 is equal to minus 7, or AB plus CD is equal to minus 11. Let's say this is equation 3. Now, if I take A plus B plus C plus D and cube it, so this will be A plus B whole cube plus C plus D whole cube plus 3 A B into CD, AB square into CD plus 3 into AB into C plus D square. Right? Yeah. So A plus B plus C plus D whole cube is equal to A cube, B cube, C cube, D cube plus 3AB, A plus D, B, 3CD, C plus D plus 3A plus B into C plus D plus 3A plus B plus C plus D. All right. So I'm using equations now 1, 2, and 3 to fill in over here. 1, 2, and 3. We get A plus B plus D plus C was A plus B plus C plus D was equal to 4. So this is equal to 4 cube is equal to A cube plus B cube plus C cube plus D cube plus 6AB, 6CD, 3 into 2 into 2 into 4, or you have a 64 is equal to A cube plus B cube plus C cube plus D cube. This is minus 6 into AB plus CD plus this is equal to 48. So you have 64 is equal to, this was equal to minus 11. A cube plus B cube plus C cube plus D cube minus 66 plus 48. Or you will have A cube plus B cube plus C cube plus D cube is equal to, this will be minus 2 and 64, 66, 130, 48. That's 282. Yeah. So this is the answer to the question 82. Let's check with the options. You have option D as your answer. Hope you understood this. Next is question number 18. If n, r are two positive integers such that r lies between 1 and n, then what is the value for this expression? Okay, we know that n minus 1 PR plus R into n minus 1 P R plus minus 1 is equal to NPR. Then let's pick up this one. NPR plus 1 plus R square. I'm not picking first of all. Let's go for this one only. N minus 1 P R minus 1 R plus 1. Question number 18. If n are two positive integers such that R is lying between 1 and n, then what is the value for this expression? All right, we know one thing that n minus 1 P R plus R into n minus 1 P R minus 1 is equal to NPR. Then NP R plus 1 plus R square n minus 1 P R minus 1 plus R plus 1 into n minus 1 P R plus R into n minus 1 P R minus 1. That's equal to n P R plus 1 plus R into R raised to power n minus 1. Not sorry, R raised to power n minus 1. R into n minus 1 P R minus 1 n minus 1 P R n minus 1 P R R into n minus 1 P R minus 1. This is equal to n P R plus 1 plus R n P R plus n P R, right? So that is n P R plus 1 R plus 1 n P R, which is equal to n plus 1 P R plus 1. Correct. So that makes option D to be the correct answer. Hope you understood this. Let's move to the next question, number 19. The number of ways in which n boys and girls can be arranged in a row so that all the boys are together and all the girls are also together is equal to which of these options? See, if you have n boys and n girls, so the number of ways of arranging n boys and n girls. Question number 19, the number of ways in which n boys and n girls can be arranged in a row such that all the boys are together and all the girls are also together is equal to. See, when all the boys are sitting, the particular arrangement can be done in n factorial ways, and when the n girls are sitting, the particular arrangement can be done in n factorial ways. Now, both can swap their places, like the first position and the second position, they can be swapped amongst the group of boys and the group of girls. So this will be multiplied by 2 as well. So this will be n factorial into n factorial into 2 factorial. Now, it matches exactly with the option, let's say option A, in which the number of boys, ways in which the n boys and n girls can be arranged in a row. This will be given by 2 n factorial ways. The number of ways in which n boys and n girls can be arranged in a row such that all the girls are together, that is different. Same way, no two girls are together, this is also different. But the number of ways in which n boys and girls can be arranged such that no two girls are together. Okay, something like G1, B1, G2, something like that. And no two boys are together. So this can be done in only this way. G1, B1, G2, B2, and so on till Gn, Bn. Correct? So now this can be done in n factorial into n factorial into 2 factorial ways. That means it matches with option D. This is the correct answer to the question. Hope you understood that. Next is question number 20. Among the positive divisors of 12600, if n1 is the number of divisors which are multiples of 3 and n2 is the number of divisors which are multiple of 14, then what is the value for n1 plus n2? See, now 12,600 can be written as 2 raised to power 3 into 3 raised to power 2 into 5 square into 7. For the multiples of 3, I'm writing as a product of the prime numbers. So for the multiples of 3, you have 12600 is equal to 3 into 2 raised to power 3 into 3 into 5 square into 7. So n1 will be equal to 3 plus 1. 1 plus 1, 2 plus 1, and 1 plus 1. That will be 4 into 2 into 3 into 2, which is equal to 48. Similarly, for multiples of 14, you have, this was your N1. So 1, 2, 6, 00. This can be written as 14, 2 square, 3 square, 5 square. So N2 will be 2 plus 1, 2 plus 1, 2 plus 1. That will be 27, right? Now you have to find out N1 plus N2, which is 48 plus 27. That is 75. So this is the answer to the question. Option A is the correct answer. Hope you understood this. Let's move to the next question, number 21. In the expansion of x minus 2y plus 3z raised to power 5, if the total number of terms is p, then the coefficient of x square y z square is q. We have to find out the value of q upon p. Okay, so the number of terms minus 2y plus 3z raised to power 5 can be written as 5 plus 3 minus 1 c 3 minus 1. So here the p is 7 c2. That means it is equal to 7 factorial upon 2 factorial into 5 factorial, which is equal to 21. Now the coefficient of x raised to power p, y raised to power q, and z raised to power r in ax, by, cz raised to power n is given by n factorial upon p factorial, q factorial, r factorial into a raised to power p, b raised to power q into c raised to power r. So q is the coefficient of x square y z square in this x minus 2y plus 3z raised to power 5. So this is given by 5 factorial upon 2 factorial into 1 factorial into 2 factorial whole multiplied by 1 square into minus 2 raised to power 1 into 3 raised to power 2. That will be equal to, when solved, this will give you minus 540. Now you have to find out q upon p. So minus 540 upon 21, which is equal to minus 180 upon 7. So this is the answer to the question, minus 180 upon 7. Option B is the correct answer. Next is question number 22. If C naught, C1, C2, Cn are the binomial coefficients in the expansion of 1 plus n raised to power n. So if Sn plus 1 is given by this, then what is the value for S11? Okay, you are given Sn plus 1 is 5 into C naught, C0, S8, C1, 11, C2, so on till n plus 1 terms. Equal to submission from r is equal to 0 till n, 3r plus 5 into cr. This is equal to submission from r is equal to 0 till n, 3 into r into cr plus submission r0 till n, 5 cr. That's equal to 3 will be taken outside. Summation r is equal to 0 n r c r plus 5 submission r is equal to 0 n c r. So n plus 1 is Sn plus 1 is equal to 3 into n into 2 raised to power n minus 1 plus 5 into 2 raised to power n. Now if I'm putting x is equal to 10, this will be S11 is equal to 3 into 10 into 2 raised to power 9 plus 5 into 2 raised to power 10. This will give me, on solving this will give me 20480. So that makes option C to be the correct answer. Hope you understood this. Let's move to the next question. Question number 23. If modulus of x is so small that x cube and the higher power of x can be neglected, then what is the approximate value for this expression? So for finding out the required question, I'll be using binomial expansion for the negative index. Using binomial expansion of for negative index. This will be equal to 1 by 16, 1 minus x by 4. Question number 23. If modulus of x is so small that x cube and the higher powers of x can be neglected, then what is the approximate value for this expression? To solve the question, I'll be using a binomial expansion for negative index. Okay, and for that, what I'll be doing is, first of all, I'll be taking common from here. This is 1 upon root 4 minus x 2 plus x raised to power 3. I'm taking root 4 common from here, and from here 2 raised to power 3 common. Okay, so this will be equal to root of 1 minus x by 4 1 plus x by 2 raised to power 3. So this will be equal to 1 upon 16 1 minus x by 4 raised to power minus 1 by 2 1 plus x by 2 raised to power minus 3. Hope you understood till here. So this now, if I'm expanding this can be written as 16 1 plus x upon 8 plus 3 upon 128x square, because x cube, like higher powers, can be neglected. I'm neglecting that. So this will be 1 minus 3x by 2 plus 3x square by 2. This is 1 by 16 1 minus 3x by 2 plus 3 by 2x square plus x by 8 minus 3x square by 16 3x square by 128. Again, I'm neglecting the x cube values. 1 by 16 whole multiplied by 1 minus 11x upon 8 plus 171 upon 128x square. So this is the answer to the question, and if I'm checking with the options, option D is the correct answer. Hope you understood. Next is question number 24. If this expression, this whole thing is equal to fx plus a upon ex plus minus 1, b upon x plus b, then f of 1 plus this whole thing is equal to. Find, you are given 6 x raised to power 4, 13x cube, 2x square minus x plus 3 whole divided by 2x square, 3x minus 2 is equal to, let's solve it. This can be written as equal to. Question number 24, if this expression is equal to fx plus a upon this plus b upon this, then what is the value for this expression? I'll pick up the LHS first. So you're given 6x raised to power 4, 13x cube, 2x square minus x plus 3 whole thing is divided by 2x square plus 3x minus 2. It's divided. So you have 6x raised to power 4, 13x cube, 2x square minus x plus 3. This is being divided by 2x square plus 3x minus 2. So this will be, first of all, 3x square, 6x raised to power 4, 9x cube minus 6x square minus plus cancel. You have 4x cube plus 8x square minus x plus 3. Next will be plus 2x, which will be 4x cube plus 6x square minus 4x minus plus cancel. 2x square plus 3x plus 3. Here will be plus 1. So 2x square plus 3x minus 2 minus minus plus you have 5 over here. So this can be written as 3x square plus 2x plus 1 plus 5 upon 2x square plus 3x minus 2. Okay. Now, you are given that this is equal to this, but I have to solve this further. So this is 3x square plus 2x plus 1. This is actually your fx. And this denominator, let's factorize it. So you will get 2x square plus 4x minus x minus 2 plus 1 plus 5 upon the two factors will be 2x plus 1, 2x minus 1. When you will solve, you get two factors as 2x minus 1 and x plus 2, which can be written as 3x squared plus 2x plus 1 plus 2 upon 2 into 2x minus 1 plus minus 1 into x plus 2. Now let's compare it with the given equation, which is fx plus a upon ax minus 1 b. All right. So here you get capital A is equal to 2 and capital B is equal to minus 1. Small a is equal to 2 and small b also equal to 2. And you have to find out, and of course the fx was equal to 3x squared plus 2x plus 1. So to find in the question was f of 1 plus a into b plus b into a. So f of 1 is 3 into 1 squared plus 2 into 1 plus 1 plus a is 2, b is minus 1, b is 2, a is 2. So this is 3 plus 2 plus is 6 minus 2 plus 4, that is equal to 8. So this is the answer to the question. Option A is the correct answer. Hope you understood this. Next is question number 25. Cot theta is minus 2 by 3 and theta doesn't lie in the fourth quadrant. What is the value for this expression? Okay. See, cot theta is given to you as minus 2 by 3. That means tangent of theta is equal to minus 3 by 2. Correct? See, theta doesn't lie in the fourth quadrant, you know. So here all are positive, here sine is positive, here tan is positive, and here cos is positive. Correct? So it is given that theta doesn't lie in the fourth quadrant, and theta tangent is given to you as negative. Theta doesn't lie in the fourth quadrant, and that means for sure. See, here all are positive, here tangent is positive, and it doesn't lie in the fourth quadrant. That means for sure theta lies in the second quadrant. See, I'm repeating this thing, how it is lying in the second quadrant, because here all sine, cos, tan are positive. Here tangent is positive, but tangent is negative. So therefore, it is not in the first and the third quadrant. And it is already given that it is not in the fourth quadrant. So it is not in the fourth quadrant as well. That means the only possible value place for theta is that it lies in the second quadrant. Okay. Then in the second quadrant, see, this is 3 and 2. I'm ignoring the sign over here. And by the Pythagoras theorem, you will get that this is equal to root of 3 square plus 2 square. That is equal to root of 13. Correct? So sine theta is equal to 3 upon root of 13. And cos theta is equal to minus 2 upon root of 13. So tangent theta, we already saw that this is equal to minus 3 by 2. What do we have to find out is this? Just fill in the values. To find was 5 sine theta, cos theta upon tangent theta plus cos theta. So this is equal to 5 into 3 upon root of 13 minus 2 root 13 square all divided by minus 3 by 2 minus 2 by 3. This is equal to 15 minus 2, that is 13 upon root 13 square whole divided by 6 minus 9 minus 4. That's equal to, they will cancel, root 13. So this is equal to 13 upon minus 13 by 6, which is equal to minus 6. So this is the answer to the question, minus 6, option B. Hope you understood this. Next question number 26. If theta lies between 540 and 630 degree, then tangent theta is 5 by 12. Then what is the value for this expression? Okay. Theta is equal to 5 by 12 and it lies between 540 and 630. That means it is in third quadrant, right? So, okay. Tangent theta is equal to 5 by 12. So this is 5, this is 12, this is root of 5 square plus 12 square, that is equal to 13. So you have a secant theta. Let's find out what are the values you are needed over here. Secant theta is equal to minus 13 upon 12 because in the third quadrant, secant is negative. Cos is equal to minus 12 by 13. Cosecant theta is equal to minus 13 by 5 because it is in the third quadrant. Cosecant is negative. Okay. Also, you have to find for theta by 2. So, if theta is lying between 540 to 630, so theta by 2 will lie between 270 and 315 degree, right? And it lies in the fourth quadrant. Then cos theta by 2, that can be written as 1 plus cos theta upon 2, which is equal to 1 minus 12 upon 2, 12 upon 13 divided by 2, which is equal to this value upon solving. Similarly, sin theta, 1 minus cos theta upon 2, 1 plus 12 upon 13 upon 2, which on solving will give you minus 5 upon root of 26. So, to find was cos theta by 2 minus 5 sine theta by 2 whole divided by root of minus 12 secant theta plus 5 cosecant theta. Okay. Cos theta by 2 minus cos theta by 2 was 1 by root of 26 plus 5 into 5 upon this whole divided by 12 secant theta. Secant theta was minus 13 by 12. So this will be minus 13 and 5 cosecant theta minus 13 again. Wait, cosecant theta was okay, minus 13 again. So this is equal to 26 upon root of 26 whole divided by root of 26. Correct. So this will give you root of 26 upon root of 26, which is equal to 1. So this is it. You have option C as your answer. Hope you understood this. Next question number 27. If A, B, C, D, the sum of all of them is equal to 2 pi, then you have to find out the value for this expression. Okay, fine. So many trigonometric questions we are solving. Not a problem. It's quite an easy one. So let's go on to find out. You have to find out cos A minus cos B plus cos C minus cos D. So cos A plus cos C minus cos B cos D. This is 2 cos a plus c upon 2, a minus c upon 2, b plus d upon 2, b minus d upon 2. Now, b plus d upon 2 is equal to a plus c upon 2 is equal to pi, because we are given that they are equal to 2 pi. Okay. So, therefore, you have cos b plus d upon 2 is equal to cos. Wait, before doing this thing, see. Question number 27, if a plus b plus c plus d is equal to 2 pi, then what is the value for cos a minus cos b plus cos c minus cos d? Okay, so this is equal to 2 pi. Fine, we have to find out cos a minus cos b plus cos c minus cos d. This can be written as cos a plus cos c minus cos b plus cos d. This can be written as 2 cos a plus c upon 2 cos a minus c upon 2 minus 2 cos b plus d upon 2 b minus d upon 2. Now, see, they are equal to 2 pi, correct? That means b plus d upon 2 is equal to pi minus a plus c upon 2, right? Because if I'm dividing both the sides by 2, so you will get a plus c upon 2 plus b plus d upon 2 is equal to pi. From there, you can get this value. Okay. So, you will get cos b plus d upon 2 is equal to cos pi minus a plus c upon 2. That makes minus cos a plus c upon 2. Therefore, you have a cos a minus cos b, cos c and cos d equal to 2 cos a plus c upon 2, a minus c upon 2, cos b minus d upon 2, cos b minus d upon 2. Now, this is equal to 2 cos a plus b upon 2 into 2 cos a plus b minus c minus d upon 4 cos a plus d minus c minus b upon 4. Now c plus d is equal to 2 pi minus a plus b. Also b plus c is equal to 2 pi minus a plus d. Therefore, a plus b minus c plus d upon 4 is equal to a plus b upon 2 minus pi by 2, right? Hence, cos a plus b minus c plus d upon 4, this 4 is just before it, upon 4 is equal to cos a plus b upon 2 minus pi by 2, which is equal to sine a plus b upon 2. And a plus b, we have done with that. A plus d now. A plus d minus c plus d b upon 4 is equal to a plus d upon 2 minus pi by 2, and cos of a plus d minus c minus b whole divided by 4 is equal to cos of a plus d upon 2 minus pi by 2, which is equal to sine a plus d by 2. Therefore, cos a minus cos b plus cos c minus cos d is equal to 4 cos a plus c upon 2 sine a plus b upon 2 into sine a plus d upon 2. Okay, let's check with the options. This is option, you have a 4 cos a plus c. This is there. Cos a plus b by 2. This is option D. Okay, this is answer to the question. Hope you understood this. Next is question number 28. If cos hx is equal to 4 by 3, then what is the value for 3 cos hx plus 3 square cos h2x plus 3 cube cos h3x? Okay, fine. So you are given that cos hx is equal to 4 by 3, which means 3 cos hx is equal to 4. Also, e raised to power x plus e raised to power minus x upon 2. This is the value for cos hx. So this is equal to 4 by 3, or this gives you e raised to power x plus e raised to power minus x is equal to 8 by 3. Let's say this is equation 1, squaring equation 1, you will get e raised to power 2x, e raised to power minus 2x plus 2 is equal to 64 upon 9, or e raised to power 2x plus e raised to power minus 2x is equal to, this will be equal to 64 minus, 64 minus 18, that is 46 upon 9. So you have e raised to power 2x plus e raised to power minus 2x is equal to 46 upon 9, or e raised to power 2x plus e raised to power minus 2x upon 2. This is equal to 23 upon 9. And this is the value for cos h2x. Cos h2x. This is equal to 23 upon 9. So 3 square cos h2x is equal to 3 into 3 square into 23 upon 9. They will cancel and you will have 23 as for this one. All right. Next is, let's pick up this one again. Because now see, we have to find out cos h3x. Now I will be picking up this one and cubing it. Cubing equation 1. You will have e raised to power x plus e raised to power minus x whole cube is equal to 8 upon 3 cube, which is equal to 512 upon 27. This is equal to a cube plus b cube plus 3ab, which is 3 into a plus b, which is 512 upon 27. So let it be like this only. And this value was equal to 8 upon, it was 8 upon 3. Cancel 512 upon 27. So e raised to power 3x plus e raised to power minus 3x is equal to 512 upon 27 minus 8. Okay, right. So this has got to be on solving. This will give you 512. So this is 296 upon 27. Similarly, e raised to power 3x plus e raised to power minus 3x divided by 2, it will be 148 upon 27. Okay, this is the value for cos h 3x. This is 148 upon 27. Now to find in the question was 3 cos hx plus 3 square cos h 2x 3 cube cos h 3x. This is equal to, what was that? That was equal to 4 by 3. Okay. So 3 into 4 by 3, 9 into cos h2x, that was equal to 23. Okay, no, that this total was 23. Yeah, I remember now. And this came out to be 27 into 148 upon 27. So this will cancel out and this will cancel. You will have 4 plus 23 plus 140. Sorry. 4 plus 23 plus 148, which is equal to 175. So this is the answer to the question 175. Option A is the correct answer. Hope you understood this. Let's move to the next question. Question 29. If in a triangle ABC, A is an acute angle, B is equal to 6, A is equal to 9. Sin A is given by this, then what is the value for 3A into cos B plus cos C? You are given B 6, C is 9, and sin A is this value. Okay, so since A is given to be the acute angle, you know one thing, that cos A is equal to this. From here, I'll calculate the value for cos A. So this is equal to 1 minus sine square A. This will be 4 into 14. That is 56 upon 9 square is 81. So this has got to be 81 minus 56 upon 81, which will be 25 upon 81. That is equal to 5 upon 9. Also, A square is equal to B square plus C square minus 2BC cos of A. So this gives you B square is equal to 6 square 36, 9 square 81 minus 2 into 6 into 9 into cos of A, which is equal to 5 upon 9. 9 and 9 will get cancelled. Cos of A, that was, okay, fine. So we have filled it up. So this is equal to 117 minus 60, which is equal to 57. Now, cos B plus cos C, this is given by C square plus A square minus B square, whole divided by 2AC plus A square plus B square minus C square upon 2AB, or A into cos B plus cos C is equal to C square plus A square minus B square upon 2C plus A square B square minus this upon 2B, because I've taken A and multiplied on this side. So let's fill in the values now. This is equal to C square. See, we just calculated. Sorry, C is given to you. It is 9. 9 square 81. A square 57 minus 36 upon 2 into 9 minus plus 57 36 minus 81 upon 2 into 6. So this gives you, okay. Okay, this is what you need to find out. Let's go for this now. You will add all of that and this is 138, 36, 102 upon 2 into 9. This is 51 upon this. And this will go at 3. So 17. 17 upon 3 plus 393, 81. So this is 12 upon 12. So this gives me 17 upon 3 plus 1. That is equal to 20. upon 3. This is the value for A cos B plus cos C. You have to find out the value for 3 cos A cos B. 3 cos B plus cos C. This will be multiplied by 3 on both the sides. So 20 will be the answer. That makes option B to be the correct answer. Hope you understood this. Let's say question number 30. If the roots of this equation are x radii of the triangle ABC, then the perimeter of the triangle ABC are. You are given the equation as x cube minus 11x square, 36x minus 36 is equal to 0. It's a cubic equation. So let alpha, beta, gamma be the roots. Okay. And now you are given that they are x radii of the triangle ABC. So S square is equal to alpha, beta, beta, gamma, and gamma alpha. Where this is your semi-perimeter. So S square is equal to 36, which makes S is equal to 6, right? See, this is equal to C upon A. And what is C? This is 36 and A is a coefficient of x cube. So this is equal to 36. That gives you S is equal to 6. That means perimeter, because it's the semi-perimeter, so perimeter will be equal to 12. That makes option C to be the correct answer. Hope you understood. Next, question number 31. Okay, now we are starting with the vector problems. OA is given to be this vector, OB is this, OC is this. Be the position vector of the point A, B, and C. Let P be the point which divides AB in the ratio 2:1. If L, M, N are the direction cosines of the vector PC, then what is the value for L plus 3M plus 2M? Let's write down the three vectors. You are given OA is I minus 3J plus K. OB I plus 3J minus 2K. And OC 4I 3J plus 5K. So let's say this is equal to A, B, and C. Okay. Now, and 3 points ABC. Let P be the point which divides AB in the ratio 2:1. So here is A, B, which is having position vector B, and this is B. It's dividing the line in the ratio 2:1. So OP will be given by 2B plus A upon 3. And what was B? It was I plus 3J minus 2K plus I minus 3J plus K whole divided by 3. So this is equal to 3I plus 3J minus 3K upon 3, or OP will be I plus J minus K. This will be the value of OP, and PC will be OC minus OP, which is 4I minus 3J 5K minus I plus J minus K. So PC will be 3I minus 4J 6K. So here you have L as 3, M is minus 4, and N is 6. So L plus 3M plus 2N. This is what you need to find. So this is equal to 3 plus 3 into minus 4 plus 2 into 6, which is equal to, they will cancel and 3 will be the answer. So that makes option D to be the correct answer. Hope you understood that. Next, question number 32. Again, a vector problem. Question number 32, the point of intersection of the line through the points this, and the plane passing through these points is given by. Fine. So first of all, equation of line passing through I minus j plus 0k and 0I plus j minus k is given by x minus 1 upon 0 minus 1. This is equal to y plus 1 upon 1 plus 1. And this is equal to z minus 0 upon minus 1 minus 0, which is equal to x minus 1 upon minus 1 is equal to y plus 1 upon 2 is equal to z upon minus 1. Let's say this is equal to r, and let's say this is equation 1. Fine. Now equation of plane passing through 2I plus j plus 0k, 0I plus 2j minus k, and I plus 0j plus 2k. So you have ax minus 2 by minus 1. This is equal to 0. This gives minus 2a plus b minus c is equal to 0. And this is equal to 0. So here you have 2a minus b plus c is equal to 0, or a plus b minus 2c is equal to 0. So that means you have a upon 2 minus 1 is equal to b upon 1 plus 4, c upon 2 plus 1. This gives me a upon 1 is equal to b upon 5 is equal to c upon 3, or x minus 2 plus 5 into y minus 1, 3 into z minus 0 is equal to 0, or x plus 5y plus 3z is equal to 7. Let's say this is equation 2. Now, point on line 1 is given by 1 minus r, 2r minus 1 minus r. Now this lies on second plane according to the question, which means 1 minus r plus 5 into 2r minus 1, 3 into minus r is equal to 7. 1 minus r plus 10r minus 5 minus 3r is equal to 7, or you have r is equal to 11 upon 6. That means the point of intersection is minus 5 upon 6, 16 upon 6, and this. Or I'm taking 1 by 6 outside and converting to vector form. You have minus 5i cap, 16j cap minus 11k cap. Right. So this is the final answer. And you have option A as your answer. Hope you understood this. Let's move to the next question. Question number 33. If the vectors BC and CD, these two vectors represent two adjacent sides of the parallelogram ABCD. Let's make that parallelogram first. So let's say this is the parallelogram ABCD. Here is A, B, C, and D. So these are the vectors. BC is given by this. Two I plus J plus K, and CD vector is I plus 2J minus 2K. Okay, so now the diagonal BD will be equal to not AB. This will be equal to BC plus CD. That is 2I plus J plus K plus I plus 2J minus 2K. This is equal to 3I, 3J minus K. Also, the diagonal AC will be given by AB
plus BC. AB is minus CD. So this is equal to minus I plus, not plus, it is minus I minus 2J plus 2K plus BC is equal to 2I plus J plus K, which is which on solving will be I minus J plus 3K. So now angle between AC and BD, this will be cos theta is equal to AC dot BD divided by their magnitude, right? And what was AC equal to? Let's write here. So this AC vector was I minus J plus 3K dot product with 3I 3J minus K divided by their magnitude. So this is equal to 1 square plus 1 square plus 3 square. Actually, here is minus 1 square, okay? So I'm just writing 1. So there is 3 square plus 3 square plus minus 1 square. So this is equal to 3 minus 3 whole divided by root of 11 into 18 plus this 19. So you have minus 3 upon root of 209. This was your cos theta. If you forgot the value for cos theta is this, so secant theta will be root 209 upon 3 minus, and tangent theta will be secant square theta minus 1, which is equal to 209 upon 9 minus 1, that is equal to 209 minus 9 upon 9, or you have tangent theta as root of 200 upon 9, sorry, not 19, 9, 200 upon 9, which is equal to minus 10 root 2 upon 3. This is plus minus. So let's check which of the options contain plus minus 10 root 2 upon 3. I have 10 root 2 upon 3, but this is only in the minus. So option B stands to be the correct answer. Hope you understood that. Next is question number 34. A plane pi passing through the point this parallel to the plane which passes through the point this and perpendicular to this vector, then the Cartesian of pi is equal to. Fine. See, let point P XYZ in the plane pi. Okay. Now, if plane pi is parallel to the plane, if plane pi is parallel to the plane having normal vector is I plus 2j minus 3k. So, plane pi having normal vector as I plus 2j minus 3k.
Question number 34. A plane pi passing through this point is parallel to the plane which passes through this point and is perpendicular to this vector. The Cartesian equation of pi is. Fine. Let's say P be the point in the plane. Right? Pi. And therefore, this is the plane is also passing through this point. Therefore, direction cosines of plane pi is given by x minus 3I plus y minus plus 4j
z minus 5k with 0.3i minus 4j plus 5k, right? Now, this plane is passing through this point and is perpendicular to this vector. If it is perpendicular to this vector, so their dot product is equal to 0. So, since they are perpendicular to this particular vector, so you can say x minus 3 into 1 plus y minus 4 into 2 z minus 5 into minus 3 is equal to 0 because the dot product is 0. They are perpendicular to each other. This will be x minus 3 plus y, 2y plus 8 minus 3z plus 15 is equal to 0, which gives you x plus 2y minus 3z plus 20 is equal to 0. So that's it. This is the required equation. Option C is the correct answer. Hope you got that. Next is question number 35. Let A be this vector. Let's write it over here. A vector is lambda I, 3j, 4k. B vector is 3i minus j plus lambda k. And C vector is lambda I plus j minus 3k. These are the three vectors with the sum integer lambda. If the volume of the parallelepiped with ABC as coterminous edges is 61 cubic units, then the number of possible values of lambda is. Okay, so sorry, I just erased. I can't get it back. Okay, anyways, so you're given that the volume of parallelepiped, this is parallelepiped, is equal to 61. These were the three vectors. So if I'm writing them in the matrix form, before that, if the volume is this is written as this, which means dot product of A with the cross product of B and C is equal to 61. So this can be written as lambda 3, 4, 3 minus 1 lambda, lambda 1 and minus 3. This is equal to 61. Let's find out the determinant. So this will be lambda into 3 minus lambda minus 3 minus 9 minus lambda square plus 4 3 plus lambda is equal to 61, or you have 3 lambda minus lambda square plus 27 plus 3 lambda square plus 12 plus 4 lambda minus 61 is equal to 0. 2 lambda square, 7 lambda minus 22 is equal to 0. Splitting the middle term, you will have a 2 lambda square, 11 lambda minus 4 lambda minus 22 is equal to 0. Or I'll take the 2 lambda common. Lambda, I'll take, I'll be taking lambda common. So I'll have 2 plus lambda minus 2 will be taken common, lambda plus 1. 2 lambda plus 1 is equal to 0. So the two factors are lambda plus 11 minus, lambda minus 2 is equal to 0. So that means lambda can be equal to 2 or minus 11 upon 2, right? So these are the two values. So let's check with the options. So you have option C as the answer. Hope you understood this. Next is question number 36. If the variance of this data is given by this, then the mean deviation of the median from the data is m. What is the value of deviation square minus m? The given data is 2, 3, 5, 8, and 12. Median is 5, of course, median value, right? It is a middle value. This is given to be 5. And mean deviation from median is given by summation of x minus median whole divided by the sum of the frequency. So this is equal to 2 minus 5. This will be 3. And 3 minus 5, 2, 0, 3, and 7. This whole is divided by number of terms 5. So this is equal to 3. right? So this was your mean deviation, which is given by m, and the variance square is equal to summation x squared upon n, which is capital N actually, minus summation x upon n square. Okay. So this is what was the values? 2, 3, 5, 8, 12. So that will be 4 plus 9, 25, 64, 144 whole divided by 5 minus 2 plus 3 plus 5 plus 8 plus 12 whole divided by 5 square. This will be equal to, that will be 144, and this, like on solving this whole thing, you will get the answer as 13.2. Okay, you will just have to do the calculations and you will get it as 13.2. So variance square minus m, that is equal to 13.2 minus 3 is equal to 10.2. So this is the answer to the question. Option A is the correct answer. Hope you understood that. Next is question number 37. If two cards are drawn at random simultaneously from a pack of 52 cards, then the probability of getting a face card and a spade card other than the face card is. Okay, so number of ways to select two cards, that is given by 52C2, because you have to, out of 52, you have to select two cards. This is 52 factorial upon 2 factorial multiplied by 52 minus 2, which is 50 factorial. So this is 52 into 51. This will cancel again. So 26. So 26 into 51. Okay, that is 1326. Now, number of ways of getting a face card and a spade card other than face card. See, what do you want in the question is probability of getting a face card and a spade card other than the face card. Okay. So the required probability is given by, see, there are 12 spade cards. So 12 face cards. Sorry, if I'm talking about the face cards, there are 12 face cards, right? 3, 3, 3, 3, 12. Out of that, you have to select one. And a spade card other than the face card. So how many? A spade card other than the face card, this will be 10C1. So 12 into 10, this is equal to 120, right? Now the required probability is 120 upon 1326, that is equal to 20 upon 221. So this is the answer to the question. Option B is the correct answer. Hope you understood that. Next is question number 38. If three unbiased dice are rolled simultaneously, then the probability that all the three dice show distinct numbers is. See, first of all, what is the sample space? Total outcomes. That will be 6 from the first one, 6 from the second, 6 from the third, that is equal to 216. Now the favorable case is, you may get any, like 1, 2, 3, 4, 5, 6, any number from the first one. And into 5. Why 5? Because the number which you received from the first one should not be included in the second one. Okay, so that means 5 ways are there. Here are 6 ways to get the first number. Here are 5 ways to get the second number. And similarly, there are 4 ways to get the third number, which is equal to 120. So the required probability is given by 120 upon 216, which is equal to 5 upon 9. That makes option C to be the correct answer. Hope you understood. Next is question number 39. 3-person A, B, C attended a recruitment test. The ratio of the chances A, B, C in getting through the test is 1, 2, 3. Probabilities to face the interview successfully are 0.8, 0.7, 0.6 respectively. If one of them is to be selected for the post, then the probability that A gets the post is, okay. So first of all, chances of A B, C are 1, 2, 3. Now, chance of A, that means the probability of A to get is 1 by 6. Similarly for B, 2 by 6. For C, 3 by 6. So let's say I denote the facing interview successfully, then probability I upon A is equal to 0.8. I upon B is this, and this is 0.6. Therefore, probability I is equal to PA into this plus PB into this, PC into this. So this is 1 by 6 into 0.8, 2 by 6, 0.7, 3 by 6, 0.6, which is equal to 4 upon 3 plus this is 14, like, sorry, 3. So this will be 7 by 30 and this will be 3 by 10. So this will give me, I'm taking the LCM as 30. So 4 plus 7 plus 9, that's 20 upon 30, or this is equal to 2 by 3. Now, probability A upon I is equal to probability A into probability I upon A whole divided by probability I. So that's 0.8 into 1 by 6 whole divided by 2 by 3, which on solving will give you 1 by 5. So this is the correct answer to the question. Option D is the correct answer. Hope you understood this. Next is question number 40. Two cards are drawn at random, one after the another, with the replacement from a pack of 52 playing cards. Then the variance of the random variable of the number of spade cards among the drawn cards is. See, let's say X be the number of spades. Therefore, X can be equal to this. Two cards are random, drawn at random, one after another. So it can be like 0 spade cards, 1 spade card, or 2 spade cards. So probability that a 0 spade card is there is given by 39 upon 52 into 39. Question number 40. Two cards are drawn at random, one after the other, with replacement from a pack of 52 playing cards. Then the variance of the random variable of the number of spade cards among the drawn cards is. Let's say, first of all, X be the number of spades. That means X can be equal to 0, 1, and 2. Now the probability that X is equal to 0 is given by 39 upon 52. Multiply 39 upon 52, which is equal to this, right? Probability that you chose 1 spade card. See, why 39? Because there are total 52 cards and there are 13 spade cards. So we are left with 39 non-spade cards.
So this is for the first non-spade card that you chose, and then see it is said with replacement. That means that spade card can be put back. So the second card that can be chosen can again be 39 by 52. Now the probability that one spade card is chosen, that is 13 upon 52, because out of 52 you have 13 spade cards. Now you have chosen that one spade card. Obviously you have 39 non-spade cards. So this is 39 upon 52 into 2, because they can be done in with replacement. So they can be done in two ways. So this will give you 1014 upon 52 square. Now the probability that both the cards chosen are spade cards. Of course, this is 13 upon 52 into 13 upon 52, which is 169 upon 52 square. You have to calculate variance of x, which is given by x square minus x whole square, which is equal to, that is equal to, c for x is equal to 0, you have 0 into this. And for x is equal to 1, you have 1 into square into this. Let's do that. So you have 0 square into 39 upon 52 square plus 1 square into 1014 upon 52 square plus 2 square into 169 upon 52 square minus this whole thing will be subtracted from 0 multiplied by 39 square upon 52 square plus 1 into 1014 upon 52 square plus 2 into this. Correct? Let's solve it further. So on solving this whole thing, you will get 1690 upon 52 square minus 1352 upon 52 raised to power 4, and this is raised to power 2. On solving this whole thing, you will get 1014 divided by 52 square, which on solving will give you 3 by 8. So this is the answer to the question 3 by 8. Option A is the correct answer. Hope you understood that. Let's move to the next question then. Question number 41. Let A be this point and B be this point. Let P be any point such that sum of distance of P from A and B is 4. Then the equation of the locus of P is which of these equations? Fine, you are given that, let's do, this is A and B, and let's say P x by xy be any variable point, then PA plus PB, or so what is PA? This is P and this is A. PA is given by root of x minus 2 square plus y square plus root of x square y plus 2 square. This is equal to 4. So this will be root of x minus 2 square plus y square whole under the root. This is equal to 4 minus root of x square plus y plus 2 square. Let's do squaring on both the sides. You will have x minus 2 square plus y square is equal to 16a square plus b square minus 2ab. So this is the one. All right. So let's open. You have x square plus 4 minus 4x plus y square is equal to 16 plus x square plus y square plus 4 plus 4y minus 8 root x square plus y plus 2 square. So you have x square, y square, y square. This will cancel. And let's see what things you will be left with. 16 plus 4y plus 4x, because this and 4 will also get cancelled, is equal to 8 root x square plus y square plus 4 plus 4y whole under the root, right? Okay, so let's divide both the sides by 4. You have 4 plus x plus y is equal to 2 root of x square y square plus 4 plus 4y. So you have ultimately 16 plus x square
I'm again squaring on both the sides, okay? Okay, fine. 16 plus x square plus y square plus 8x, 2xy, 8y is equal to 4x square, 4y square, 16y plus 16. Okay. Now this will be on solving this will give you 3x squared minus 2xy plus 3y squared minus 8x plus 8y is equal to 0. So let's check which of these options is the correct one. You will find out that option B is the correct answer. Hope you understood this. Let's move to the next question, number 42. So let P be the point to which origin has to be shifted by the translation of axis so as to remove the first degree terms from the equation this. If the origin is shifted to P by translation of axis, then the transformed equation this becomes what? See, to shift the origin so that the first degree terms are eliminated, to shift the origin so that first degree terms are eliminated, you have to substitute x with x plus h and y with y plus k. So in 3x square plus y square minus 6x plus 4y plus 4 is equal to 0. We have 3x plus h square, y plus k square, 6x plus h, 4 y plus k plus 4 is equal to 0. That gives you 3x square, h square, 2x h plus, I'm concatenating the terms because I want to make them perfect squares, like y square, 2ky, k square, minus 6, x plus h, plus 4, y plus k, plus 4 is equal to 0. Okay, now equating the coefficients of the first degree term to 0 because it is said that first degree terms are eliminated. Equating the first degree terms to 0. You will have 6h minus 6 is equal to 0. 2k plus 4 is equal to 0. That gives you h is equal to 1 and k is equal to minus 2. Now origin is shifted to P in. Origin is shifted to P in 2x square, 3xy minus 5y square plus 2x minus 23y minus 24 is equal to 0, which makes it 2x plus 1 square, 3 plus 3x plus 1, y minus 2, minus 5, y minus 2 square, plus 2x plus 1, minus 23, y minus 2, minus 24 is equal to 0. Okay, so this is 2x square, 2x plus 1 plus 3 xy minus 2x plus y minus 2 minus 5 y square minus 4y plus 4 plus 2x plus 2 minus 23y plus 46 minus 24 is equal to 0, which on solving will give you 2x square plus 3xy minus 5y square is equal to 0. So this is the answer to the question. That makes option C to be the correct answer. Hope you understood that. Let's move to the next question.
Question number 43. If alpha is the angle made by the perpendicular drawn from the origin to this line with positive x-axis in positive direction and ax plus by is equal to 1, is the equation of the line passing through this point with tan alpha as its slope, then what is a plus ab plus b? Okay, you are given alpha is the angle made by the perpendicular from the origin to this line with the positive x-axis. Okay, length of perpendicular from origin to the line. This equation is 3x minus 4y plus 5 is equal to 0. And here the slope is equal to, okay. See, I'm putting, you have the origin, right? So the length will be given by, this is 3 into 0 minus 4 into 0 plus 5 whole divided by 3 square plus 4 square, actually minus 4 square. So that is 5 upon root of 25, which is equal to 1. So the length of the perpendicular from the origin to this line is equal to 1 unit. Now, you're given that alpha is the angle. If alpha is the angle made by perpendicular, then equation of line in normal form, this is x cos alpha y sin alpha is equal to p. Also, and see this p is equal to 1, so x cos alpha plus y sin alpha, this is equal to 1. On comparing equation 1 with, equation 1 with 3x minus 4y plus 5 is equal to 0, you get x into minus 3 by 5 plus y into 4 by 5 is equal to 1. Question number 43. If alpha is the angle made by the perpendicular drawn from the origin to this line with positive x-axis in the positive direction and ax plus by is equal to 1 is the equation of the line passing through this point with tan alpha at its slope, then a plus ab plus b is equal to. Okay, see, length of perpendicular from origin to the given line 3x minus 4y plus 5 is equal to 0. The length of perpendicular is given by, let's say that is L. This is 3 into 0, you know, origin has the coordinate 0, 0. So 3 into 0 minus 4 into 0 plus 5 whole divided by root of 3 square plus minus 4 square under the root. So this is 5 upon root of 25. That will be equal to 1. The length will be equal to 1. Now, if alpha is the, you're given alpha is the angle made by perpendicular, then equation of line in the normal form is given by x cos alpha plus y sin alpha is equal to p, or you can say x cos alpha sin y sin alpha, this is equal to 1 because the distance is 1. On comparing it with the general equation, which was 3x minus 4y plus 5 is equal to 0. Let's bring it in this form. So you can write it as x into minus 3 by 5 plus y into 4 by 5 is equal to 1. So let's compare both of these equations now. On comparing, you will have cos alpha is equal to minus 3 by 5
and sine alpha is equal to 4 by 5, which gives you tangent of alpha is equal to minus 4 by 3. Now, equation of the line passing through, equation of the line passing through 1 minus 1, not this, 1 minus 1, and slope minus 4 by 3 is y minus of minus 1, it will be y plus 1 is equal to minus 4 by 3 x minus 1. This will be 3y plus 3 is equal to minus 4x plus 4, or you have 4x plus 3y is equal to 1. Now let's compare it on comparing with the given equation. This, we have a is equal to 4 and b is equal to 3. And you have to find out a plus ab plus b. That was to find. So this is 4 plus 4 into 3, 12 plus 3, which is equal to 19. So this is answer to the question. Option D is the correct answer. Hope you understood this. Next is question number 44. If L1 is a line passing through the point minus 4 comma minus 3 and perpendicular to this line, then the distance of P from this line measured along the line L1 is. Okay. So here you have equation of L1 perpendicular to 3x minus 4y plus k is equal to 0 is 4x plus 3y plus lambda is equal to 0, right? Now, it passes through 4 comma minus 3. Therefore, this makes 4 into 4 plus 3 into minus 3 plus lambda is equal to 0, which gives you 16 minus 9, that is 7 plus lambda is equal to 0, which gives you lambda is equal to minus 7, right? So the line 1, it was 4x plus 3y minus 7 is equal to 0. This is your first line, and the given line and given line, which is 5x minus 3y minus 2 is equal to 0. Let's say this is number 2. Say this is the given line. So let's solve both equations, solving 1 and 2. Solving 1 and 2, you will get, let's add them. So you will have 9x minus 9 is equal to 0, which gives you x is equal to 1. And for x is equal to 1, you will find out y is also equal to 1. So the point of intersection is 1 comma 1. So distance between 1, 1 and 4 comma minus 3 is, that is given by 4 minus 1 square plus minus 3 minus 1 square, which is equal to 3 square 9. And this is 16, which will give you the answer as 5. So this is the answer to the question. Option A is the correct answer. Hope you understood this. Next is question number 45. If the line L1 passing through the point of intersection of the lines 2x plus 3y minus 5 is equal to 0, and this, divide the line segment joining the points this and this in the ratio 2:1. If the equation of L1 is given by this, then what is the value for 33a minus b? Okay. So you are having that L1 is passing through the intersection of these two lines, and divide the line segment joining this in the ratio 2:1. First of all, L1 is passing through the point of intersection of these two lines. Let's find out that if L1 is passing through the point of intersection of 2x plus 3y minus 5 is equal to 0 and 4x minus 5y plus 7 is equal to 0. If L1 is passing through the point of intersection of these two lines, then L1 equation is given by 2x plus 3y minus 5 plus lambda 4x minus 5y plus 7 is equal to 0. This gives you 2 plus 4 lambda x 3 minus 5 lambda y 7 lambda minus 5 is equal to 0. This is equation 1. This line divides a line segment. This line divides the line segment joining these 2 points. Line segment joining 2, 3 and 1, minus 1 in the ratio 2:1. Then by section formula, you will have x is equal to, that will be 2 into 1, 2 into 1 plus 1 into 2 divided by 1 plus 2. And the y will be given by 2 into minus 1 plus 1 into 3 whole divided by 1 plus 2. X will be 4 by 3 and y will be equal to 1 by 3. Okay. So here you have x comma y is equal to 4 by 3 comma 1 by 3. This lies on equation 1. Okay. So I'm putting that in equation 1, which is 2 plus 4 lambda into 4 upon 3 plus 3 minus 5 lambda into 1 by 3 plus 7 lambda minus 5 is equal to 0. That is 8 plus 16 lambda plus 3 minus 5 lambda plus 21 lambda minus 15 is equal to 0. I've multiplied both the sides by 3. This gives you 32 lambda minus 4 is equal to 0, or lambda is equal to 1 by 8. Okay. Now, again equation 1. From equation 1, we get 2 plus 4 into 1 by 8 x plus 3 minus 5 into 1 by 8 y plus 7 into 1 by 8 minus 5 is equal to 0. That gives you 20x plus 19y plus minus 33 is equal to 0, or this will be, I'm getting in standard form, so 22 upon 33 x plus 19 upon 33 y is equal to 1. On comparing with the equation ax plus by is equal to 1, you have a as 20 upon 33 and b as 19 upon 33. So you have to find 33 a minus b, which is equal to 20 upon 33 minus 19 upon 33, which is equal to 33 into 1 upon 33, which is equal to 1. So the answer to the given question is option C. Hope you understood this. Next is question number 46. If ABC be a triangle with A as this point, and for x minus 3y minus 5 is equal to 0, and this is equal to 0, the perpendicular bisectors of AB and BC respectively, then the length of AC is. Let's make the figure to understand the problem. First, here you have the triangle ABC. According to the question, this line and this line perpendicular bisectors of AB and BC. So let's make the perpendicular bisectors of this and this BC as well. Okay, this is x plus 5y minus 9 is equal to 0, and this one is x minus 3y minus 5 is equal to 0. A point is given to you as 1, 2, and let's say this is x1, y1, and BC is x2, y2. Okay, so I hope you are clear with everything now. Let's start with solution. Let's say this is the point D and E. Okay, now let's find out the coordinates of point D, because it is the midpoint, so easy. Coordinates of D, they are equal to x1 plus 1 upon 2, y1 plus 1 upon 2. So it's given that this is the equation of the line. That means D is lying on this line. D lies on x minus 3y minus 5 is equal to 0, and this is perpendicular to AB. So that means product of their slopes is equal to 0. Sorry, minus 1, right? What is the slope of this line? X minus 3y minus 5 is equal to 0. The slope is x minus this, from this is equal to y. So here the slope is equal to 1 by 3. And for the line AB, the slope is given by y1 minus 2 upon x1 minus 1. Okay, so the product of these two slopes is equal to minus 1, which means 1 by 3 into y1 minus 2 upon x1 minus 1 is equal to minus 1. So let's make the equation. You have y1 minus 2 is equal to 3 into x1 minus 3 into x1 minus 1. y1 minus 2 is equal to minus 3 x1 plus 3. Or you have 3x1 plus y minus 1, y1 minus 5 is equal to 0. Let's say this is equation 1. Now, D lies on this line, right? So that means the point D had the coordinates as x1 plus 1 upon 2 minus 3 y1 plus 2 upon 2 minus 5 is equal to 0, which on solving will give you x1 minus 3 y1 minus 15 is equal to 0. Let's say this is equation 2. Okay. Yeah. So solving equation 1 and 2, you have the equation 1 as 3x1 plus y1 minus 5 is equal to 0. And this one was x1 minus 3y1 minus 15 is equal to 0. Let's multiply this equation with 3. So you will get 9x1 plus 3y1 minus 15 is equal to 0. x1 minus 3y1 minus 15 is equal to 0. 10x1 minus 30 is equal to 0, or you will get x1 as 3. And on solving, you will get y1 as minus 4. So what is the point B now? It is D point, not B. Not, sorry, this is B only. So B point is 3 comma minus 4, right? Similarly, let's find out the coordinate for E. Now, E will be having the coordinate as x2 plus 3 upon 2, y2 minus 4 upon 2. Now, you know E lies on x plus 5y minus 9 is equal to 0. So you have x2 plus 3 upon 2 plus 5 y2 minus 4 upon 2 minus 9 is equal to 0. This gives you x2 plus 5y2 minus 35 is equal to 0. Let's say this is equation 3. Also the same thing. 5x plus 5y minus 9 is equal to 0 is perpendicular to BC. What is the slope of this line? Y is equal to minus 1 by 5x plus 9 by 5. So, yeah. So the slope over here is minus 1 by 5. And I'm taking the other point. So the slope of BC, this is given by y2 plus 4 upon x2 minus 3. Now, according to question, the product of two perpendicular slopes is equal to -1. So, 1 is 1 by 5, y2 plus 4 upon x2 minus 3 is equal to -1. That gives you, on solving, 5x2 minus y2 minus 19 is equal to 0. This is equation 4. Solving 3 and 4. We get x2 5 and y2 as 6. Let's do this over here. So you had from the equation 3 was x2 plus 5y2 minus 35 is equal to 0. And here you had 5x2. I'll multiply this equation with 5. All right. So you have 25 x2 minus 5 y2 minus 95 is equal to 0. They will cancel and you have 26 x2 is equal to 130. That makes x2 as a, wait, yeah, 5. Okay. And on solving, you will get y2 as 6. So the C point comes out to be 5, 6. What you had to find out in the question was the length of AC. We got the A, we got the C point as well. So let's find out AC. A point is having the coordinates. It was, wait, what was it? It's coordinates 1, 2. And C had 5, 6. So AC will be equal to root of 5 minus 1 square, 6 minus 2 square, which is equal to 4 square plus 4 square under the root. On solving, this will give you 4 root 2. So this is the answer to the question. Let's check. You have option D as the correct answer. Hope you understood this. Next is question number 47. If ax square minus xy minus 3y square minus 5x plus 20y plus c is equal to 0 represents a pair of lines passing through this point, then a minus c is equal to. Fine. So let's compare this equation with the general equation. This is a pair of lines. So what is the general equation for that? It is ax square plus 2h xy b y square 2gx 2fy plus c is equal to 0. If I'm comparing this equation with this general equation, you will get a is equal to a, h is equal to minus 1 by 2, b is equal to minus 3, g is minus 5 by 2, f is equal to 10, and c is equal to c, small c. Now, given equation represents a pair of straight lines. If the determinant of a, h, g, h, b, f, g, f, c, this is equal to 0. Let's fill in the values. So this is a minus 1 by 2, minus 5 by 2, minus 1 by 2, minus 3, 10, minus 5 by 2, 10, c. This is equal to 0, which is minus 12 AC minus 400 A minus C plus 175 is equal to 0. Let's say this is equation 1. Now the given pair of line is passing through 2, 3. It's given. Now pair of lines is passing through 2, 3. Then 4A plus C plus 17 is equal to 0. See, you have this, I'm feeling like x is equal to 2 and y is equal to 3 in this line. So you will get this equation 4a plus c plus 17 is equal to 0. So this gives you c is equal to minus 4a minus 17. Let's fill this value of c in this equation number 1, this equation. So filling C in equation 1. You will have that was okay. This will be minus 12a minus 4a minus 17 minus 400a minus 4a plus 17 plus 175 is equal to 0. This will give me 48a square plus 17 12s are that is equal to 204a minus 400a plus 4a plus 17 plus 175 is equal to 0. Then 48a square plus 192 minus 192a is equal to 0. 48a square minus 192a plus 192 is equal to 0. Dividing both sides by 48, you have a square minus 4a plus 4 is equal to 0, which is a minus 2 whole square is equal to 0. That means a is equal to 2. And what you needed to find out in the question was value of a minus c. That means I need the value of c as well. C was equal to minus 4a minus 17. So this is minus 4 into 2 minus 17, that is minus 25. C minus A will be equal to minus 25 minus 4. No, sorry, A was 2. So that's it, minus 27. C minus A, this is what you need to find out. Sorry, it is A minus C what you need to find out. A minus C, this is 2 minus of minus 25, which is equal to 27. So this is answer to the question 27. Option B is the correct answer. Hope you understood this. Next is question number 48. Let a chord AB subtend an angle of 60 degree at the center C, 2, 3 of the circle S. If the equation of AB is given by this, then the equation of the circle S is which of these options? Let's make the figure. So you have this circle. This is the given circle, and this is the center, which is given by the point 2, 3. And here is the chord AB like this. So AB subtend an angle of 60 degree at the center. That means this is 60 degree. And if the equation of AB is given by this, AB is having the equation x plus y plus 1 is equal to this, and angle ACB is equal to 60 degree. Okay, so see, if this is 60 degree, then these two are equal lines. That means this is also 60 and this is also 60. Triangle ABC is equilateral triangle. All right. So you have a AC is equal to AB is equal to BC is equal to radius, let's say R, right? So let's make this perpendicular. CM. I'm drawing a perpendicular. CM is perpendicular to AB. So AM is equal to MB, right? Because it's a perpendicular bisector. Now, CM is equal to, because you are given this equation of the line, so CM, this is the point, and this is the equation of the line AB as x plus y plus 1 is equal to 0. It will be 2 into 1 plus 3 into 1 plus 1 whole divided by 1 square plus 1 square. This is equal to 6 upon root 2 or 3 root 2. This is the value for CM. Now ACM is a right angled triangle. Then you have AC square is equal to CM square plus AM square, or R square is equal to 18 plus R by 2 whole square. So this is 3 by 4. R square is equal to 18, or you have R square is equal to 24. Now, equation of circle. This is given by x minus 2 because this is the center square. Y minus 3 square is equal to radius square, which is equal to 24. Let's open x square plus 4 minus 4x, y square plus 9 minus 6y is equal to 24, which gives you x square plus y square minus 4x minus 6y minus 11 is equal to 0. This is the equation of the circle. So you have option C as your answer. Hope you understood that. Let's move to the next question.
Question number 49, students. Before starting with this question, here's a quick reminder to visit our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers. Similar type of many more entrance exam question papers are also available. You must download our app. The link is available in the description box for a better preparation of your examinations. A very best of luck. Here we start with question number 49. It says let 6, 8 be the x, y intercepts made by the circle S given by x squared plus y squared plus 2gx plus 2fy plus c is equal to 0 respectively. If gx plus fy plus 1 is equal to 0 is a line passing through 1 minus 1, then the radius of the circle S is equal to 0 is. You are given two things. First, x-intercept is given to you, that is 6. Also, you are given the y-intercept, that is equal to 8. X-intercept is given by 2 root of g square minus c. That means this is equal to 6, which gives you g square minus c is equal to 3. Or squaring both sides, g square minus c will be equal to 9, which gives you c is equal to g square minus 9. Similarly, over here, the y-intercept, you have 2f square minus c is equal to 8. That gives you f square minus c is equal to 4. Squaring both sides, you have f square minus c is equal to 16. Or you have c is equal to f square minus 16. Okay, so let's say this is equation 1 and this is 2. So from equation 1 and 2, you get f square minus g square is equal to 7 because they both are equal. So you get f square minus g square is equal to 7, which gives you f plus g into f minus g is equal to 7. Let's say this is equation 3. Now you are given that gx plus fy plus 1 is equal to, okay, 0. Passes through 1 minus 1. That makes it minus, not minus, sorry, g minus f is equal to minus 1. Or f minus g is equal to 1. If I use this in equation 3, so in equation 3, you have f plus g is equal to 7. Okay, so I have these two equations, f minus g is equal to 1, f plus g is equal to 7. Let's use these two equations. So f plus g 7 and f minus g is equal to 1. This gives me 2f is equal to 8 or f is equal to 4. For that, if f is equal to 4, then g will be equal to 3. So you got the value of f as 4 and g as 3. Now let's get back to our question. What we had to find out, radius of the circle, and radius of the circle is given by radius. Okay, for that I need c also. First of all, let's calculate c. C was equal to g square minus 9. So 3 square minus 9, this is equal to 0. So c came out to be 0. Radius is given by root of g square plus f square minus c. So this is root of 4 square plus 3 square plus minus 0. That is equal to root of 25, which is equal to 5. So that means we got the answer as 5. Option B stands to be the correct answer. Hope you understood this. Let's move to the next question, number 50. If 3, 1 and minus 2, 4 are the points on the circle S whose center is lying on this line, then the parametric equations of S are which of these options? Fine. So the circle we are talking about, let the equation of the circle be x square plus y square plus 2gx plus 2 fy plus c is equal to 0. Let's say that. Let's say this is equation 1. Now, circle passes through 3, 1 and minus 2, 4. Therefore, this becomes the first equation. It will be 9 plus 1 plus 2gx, that is 6g, 2f plus c is equal to 0. That makes 6g plus, this is for the point 3, 1, 6g plus 2f plus c plus 10 is equal to 0. This is equation 2, and let's say this is equation 1. Okay, and for the point, the second one, which is minus 2, 4, you have this as a minus 2 square plus 4 square plus 2 into g into x plus 2 into f into y plus c is equal to 0. So this is 4 plus 16, 20 minus 4g plus 8f plus c is equal to 0. This makes minus 4g plus 8f plus c plus 20 is equal to 0. This is your equation 3, right? Next, also let's see the center. You know, center of the circle is given by minus g minus f. This is lying on the line x minus 1 plus x, x minus y plus 1 is equal to 0. It is given. So that means minus g plus f plus 1 is equal to 0. Let's say this is equation 4. Now solving equation 2 and 3, we get 10g minus 6f. See, this is equation 2 and 3. So I'm solving, then you will get 10g minus 6f minus 10 is equal to 0, or g minus 3 by 5 f minus 1 is equal to 0. Let's say this is equation 5. Now solving 4 and 5. You get f is equal to 0 and g is equal to 1. If you will solve 4 and 5, you will get these two things. Now the equation 2 will be using equation 2. What was that? This was equation 2. Using equation 2, we get c is equal to minus 16. So equation of the circle becomes x squared plus y squared plus 2x minus 16 is equal to 0, or you have x plus 1 whole square plus y square is equal to 17 root whole square. See, I've used it over here, x squared plus 2x plus 2. So, okay, so this is, see, I've used this x squared plus 1 plus 2x as one thing, and I'm subtracting 1 minus this. This is equal to 0. So this makes x plus 1 whole square. I missed y square. Plus y square is equal to 17. So root and square. What I'm doing over here is I want to find out the radius. Okay. Sorry, I want to get into the parametric form. So the parametric form will be x plus 1 is equal to root 17 cos theta. Y is equal to root 17 sine theta. So x is minus 1 plus this, and y is this. All right, so this is the answer to the equation. Let's check with the options. Here you have option A as the answer. Hope you understood this. Next is question number 51. It says let S be given by S be a circle, which is given by this equation. And P and Q be the 2 points. Then the point of intersection of the polar of P with respect to S is equal to 0 and chord with Q as the midpoint to S is equal to 0 is. Okay, So first of all, let's write down the equation of the circle, which is given to you: x square y square minus 8x plus 10y plus 5 is equal to 0. Now you're given these two divides, p as 1, 1 and q 1 minus 1. So equation of polar of p1, 1, s1 is equal to 0. This is 3x. Let S be this circle. This is the given equation of the circle, and P and Q be these 2 points. Then the point of intersection of the polar of P with respect to S is equal to 0, and the chord Q as the midpoint to S is equal to 0 is. Okay, so you're given the equation of the circle as x square plus y square minus 8x plus 10y plus 5 is equal to 0. And the given 2 points are P1, 1, Q1 minus 1. All right. Now, equation, first of all, of polar P with respect to S is equal to 0 is given by equation of polar P with respect to S is equal to 0. It's given by the formula is x1, y1 plus g into x plus x1 plus f y plus y1 plus c is equal to 0. Here you have x into 1 plus y into 1 plus g. G is half the coefficient of x, so this is minus 4x plus 1 plus f is half the coefficient of y, so this is 5y plus 1 and c is equal to 5. So let's open. You have x plus y minus 4x minus 4 plus 5y plus 5 plus 5 is equal to 0, or you have minus 3x plus 6y. That makes plus 6 is equal to 0. I'm dividing both the sides by minus, so this will be 3x minus 6y minus 6 is equal to 0. So let's say this is equation 1. The second one, you want to find out the equation of the chord with the q as the midpoint. Equation of chord with q as the midpoint. This is given by the formula x minus x1 into x1 plus g, y minus y1, y1 plus f is equal to 0. Now let's fill in the value. You had the q point as, that was 1 minus 1, right? So this is supposed to be x minus 1, 1 plus g was minus 4 plus y minus minus plus, and this is minus y, and f is plus 5. 0. This is minus 3x minus 1 and 4y plus 1 is equal to 0. Minus 3x plus 3 plus 4y plus 4 is equal to 0. Multiplying, no, let it be like this only. Plus 7 is equal to 0. So let's say this is equation 2. Adding 1 and 2. Adding 1 and 2. You had 3x minus 6y minus 6 is equal to 0, and minus 3x plus 4y plus 7 is equal to 0. They will cancel, and you will have minus 2y plus 1 is equal to 0, which gives you y is equal to 1 by 2. And let's find out the corresponding value for x. You had minus 3x plus 4y plus 7 is equal to 0, or minus 3x plus 4 into 1 by 2 plus 7 is equal to 0. Here you have minus 3x and plus 9 is equal to 0. This gives you x is equal to 3. So the point of intersection is 3, 1 by 2. All right, this is the answer to the question. Let's check. You have, this is not in the options actually. This is the answer to the question. I'd say this is option E, and 3, 1 by 2. This is the answer to the question. Hope you understood this. Next is question number 52. If the angle between these two circles is pi by 3, then which of the following is true about k, because all the options involve k. So let's talk about the nature of k. You are given the two equations of the circles x squared plus y squared minus 2x plus 2y plus 1 is equal to 0, and x squared plus y squared minus plus 2x minus 2y plus k is equal to 0. Let's say this is equation 1 and this is equation 2. On comparing it with the general ones, which is x square plus y square plus 2gx plus 2fy plus c is equal to 0. And x1 square, sorry, x square plus y square. This is the first one for the first one, and now for the second one, plus 2g1x 2f1y plus c1 is equal to 0. So from here, you see g is equal to half the coefficient of x. So the g is equal to minus 1. F, half the coefficient of y. This is 1 and c is 1. From here, you have g1 half the coefficient of x in the second equation. This is equal to 1. F is equal to half the coefficient of y, which is minus 1. And c1 is equal to k. Okay, fine. Now, you are given angle between the circles is pi by 3. Right? Angle between the circles is pi by 3, which means cos pi by 3 is equal to c plus c1 minus 2g g1 f1 whole divided by 2 root g square plus f square minus c multiplied by g1 square f1 square minus c1. Okay, this is 1 by 2, and let's fill in the values. You have 1 plus k minus 2 minus 1 minus 1 whole divided by 2 root of 1 plus 1 minus 1 multiplied root of 1 plus 1 minus k. This 2 and this 2 will cancel. You will have 1 is equal to 1 plus k plus 4 upon root of 1, which is 1, of course, and this is root of 2 minus k. Okay, that makes root of 2 minus k is equal to k plus 5. Let's do squaring on both the sides. You will have 2 minus k is equal to k square plus 5 square, which is 25, plus 10k. That makes k square plus 11k plus 23 is equal to 0. Let's use the quadratic formula, which is given by when you have to find out x, this is minus b plus minus b square minus 4ac upon 2a. So this will be minus 11 plus minus root of 11 square, which is 121 minus 4ac. So 4 into 23, which is 92, whole divided by 2a, that means 2, which is equal to minus 1 plus minus root of 29 upon 2. This is, since 29 is not a perfect square, so k is an irrational number for sure, right? So let's check with the options. Which one you have? You have option B as your answer. Hope you understood this. Let's move to the next question, number 53. Let this line intersect this circle in 2 points A and B. If AB is the diameter of this circle, then what is the value for G plus F? Okay, let's let's write down. So you're given this equation of the circle, equation of the line as x minus y plus 1 is equal to 0. You can say y is equal to x plus 1. And the given equation of the circle is x squared plus y squared plus 2x 2y plus 1 is equal to 0. You want to actually they're intersecting at 2 points A and B. So let's fill y is equal to x plus 1 in this equation. You will have x squared x plus 1 square plus 2 plus 2 into x plus 1 plus 1 is equal to 0. This will be x squared plus 1 plus 2x plus 2x plus 2x plus 2 plus 1 is equal to 0. So 2x squared plus 6x plus 4 is equal to 0, dividing both sides by 2, x square plus 3x plus 2 is equal to 0. So the two factors will be x plus 1 and x plus 2 is equal to 0. That means x can have the value for minus 1 and minus 2. See, let's find out the corresponding value for y also. So when x is equal to minus 1, you will solve. You'll get the value of y is equal to 0. You can use this. Okay. And when x is equal to minus 2, the corresponding value of y is equal to minus 1. Let's say this is point A, which is minus 1 comma 0, and this is point B, which is minus 2 comma minus 1. So now you know you're given in the question AB is the diameter of the circle. Now what is you have to compare it with this one and then find out the value of g plus f. For that, let's make the equation of the circle, which is given by, like you have these 2 points through which it passes. So equation of such a circle for which the 2 points are given is given by x minus of minus 1. This is plus 1 into x minus of minus 2 plus 2 plus y minus 0 into y minus of minus 1, y plus 1 is equal to 0. This will be x square plus 2x plus x. This will be 3x plus 2 plus y square plus y is equal to 0. Or you have x square plus y square plus 3x plus y plus 2 is equal to 0. Let's compare it with the general equation which was given, x square plus y square plus 2 gx to fy plus c is equal to 0. Here you have g as 3 by 2, f as 1 by 2, and c as 2. Right, what you had to find out was g plus f. To find was g plus f. So this is equal to 3 by 2 plus 1 by 2, which is equal to 2. And in terms of c, this is equal to c. That means you have option C as your answer. Hope you understood this. Let's move to the next question, number 54. If the focal distance of the point P2, y1 is on this parabola is 3, then the equation of the tangent at P to the given parabola is given by. Okay. So first of all, this is the equation of the parabola, and focus is given by k by 4, 0. Now you're given that P2y1 lies on this parabola. Also, distance between focus and P is equal to 3, which means the root of focus was this and P is this. So this is y1 minus 0 square plus 2 minus k upon 4 whole square is equal to 3, which gives you y1 square plus k square upon 16 plus 4 minus k is equal to 9. I'm squaring on, I'm taking the square on the right hand side. So this will be, okay, one thing, you are given y is equal to, sorry, it was equal to kx. That's it, yeah. Y was equal to kx, and for the point 2 comma y1, it will be y1 is equal to k into 2. So this is equal to 2k. So I can write it like 2k whole square plus k square upon 16 plus 4. Okay, I'll do one thing. I'll write minus k is equal to 5. I'm taking 16, like multiplying 16 on both the sides. You have first of all 4k square plus k square upon 16 minus k minus 5 is equal to 0. Or you have 64k square plus k square minus 16k minus 80 is equal to 0. Okay, this becomes a I did a mistake over here. This was y square. So this sum has to be done again from this point. This whole thing will not be considered. Okay. I'm repeating because I didn't take the y square over here. So now this whole thing will be repeated. I'm taking the question again from here.
which was okay, y1 square plus 2 minus k upon 4 whole square is equal to 9. I'm taking the sum from here. Y1 square was equal to 2k plus 4 plus k square upon 16 minus k is equal to 9. This makes k square upon 16 plus k minus 5 is equal to 0. That makes k square plus 16k minus 80 is equal to 0. So the two factors will be 20 and 4k. You have k plus 20 minus 4k plus 20 is equal to 0. So k plus 20, k minus 4 is equal to 0. You have the two values of k as minus 4, sorry, plus 4 and minus 20. Right? You can't take the value of k as negative because y square is equal to kx. So k cannot be equal to negative. That means k is equal to 4 only. I hope you are clear till here. Now the given point is the point was 2 comma y1. So this is equal to y1 was equal to y1 square was equal to 2k, which was equal to 2 into 4, that is equal to 8. So y1 square was 8. So y1 is equal to plus minus 2 root 2. Right? So this point P now becomes 2 comma 2 root 2. Okay. Now, next, what do you need to find out in the question was you have to find the equation of the tangent at P to the given parabola. All right. So, equation of tangent at P to the given parabola. The general equation for that is y1 is equal to 2a x plus x1. So what is a in this question? You are given y square is equal to kx or y square is equal to 4x. That means a over here is equal to 1. And this is y1 and this is x1 and this is y1. So y into plus minus 2 root 2 is equal to 2 into 2 plus, sorry, x plus 2. Okay, now this will be plus minus 2 root 2 y is equal to 2 into x plus 2. 2 and 2 will cancel. You will have x plus minus 2 root y plus 2 is equal to 0. This is the equation of the tangent. See, this is plus minus, so you can take it like this because in either case there will be two values, plus and minus. All right. So now let's check with the options. It was yeah, option D is the correct answer. Hope you understood this. Let's move to the next question. Question number 55. Normals are drawn from the point P80 to this parabola. Theta is the acute angle between two non-horizontal normals among them. Then what is the tangent of theta? You are given the equation of the parabola as y square is equal to 12x. If I compare it with the general equation, which is y square is equal to 4ax, so you have a is equal to 3. Now, equation of the normal having slope m is given by y is equal to mx minus 2am minus am cube. Y is equal to mx minus, if I'm putting the value of a, this is minus 6m minus 3m cube. Now normals are passing through the point P, which is defined by 8 comma 0. Therefore, let's fill in the value for this. So you will have a this will be 8m minus 6m minus 3m cube is equal to 0, right? Okay, so this will be 2m minus 3m cube is equal to 0. I'm taking the m common. 2 minus 3m square is equal to 0, which means m is equal to 0 or m square is equal to 2 by 3, right? That gives you m is equal to
plus minus root 2 by 3. Okay, so now the slope of non-horizontal normals, slope of non-horizontal normals, of course, this is m is equal to plus minus root 2 by 3. Let's say m1 is equal to root 2 upon root 3 and m2 is equal to minus root 2 upon root 3. So tangent of theta is the angle between, the tangent of the angle between them is the m2 minus m1, 1 plus m1 into m2, which is equal to minus this minus this whole divided by 1 plus this will be minus of root 2 upon 3 into plus of this, which is equal to 2 into root 2 upon root 3 minus whole divided by 1 minus 2 upon 3. Hope you understood it here. So this is equal to this minus, and this is 1 by 3. All right. I'm removing the modulus sign and ignoring the negative sign. So 2 root 2 upon root 3, this is divided by this. So this is like this, which is 2 root 6. So this is the answer to the question 2 root 6. Option B is the correct answer. Hope you understood this. Let's move to the next question. Question number 56. Let S and S dash be the foci of the ellipse E and E be the one end of the minor axis. Let S dash SB be angle S dash SB be pi by 6. And this point be a point on E. If x-axis is the major axis, y-axis is the minor axis of the ellipse E, then the sum of the square of lengths of major and minor axis is. So basically what you need to find out, A plus B, major and minor axis. Basically, we want to find out major and minor axis. Let's make the figure because you are given in the question that x-axis is the major and y-axis is the minor axis. So this is the ellipse, something like this, where x-axis is the major and y-axis is the minor one. And these are the foci of the ellipse. So let's say this is S and S dash, and this foci is given as a comma 0, and this one S dash is given by minus a comma 0. The general equation of the ellipse will be given by x square upon a square, y square upon b square is equal to 1. If I'm taking this as a point B, let this be the point B. So this is origin. OS is equal to AE, OB is equal to B. So this point becomes 0 comma B. Okay. Now also you are given that angle S dash SB is equal to pi by 6. So tangent pi by 6 is equal to OB upon OS in triangle this OBS. Okay, so in triangle OBS, tan pi by 6 is equal to this. What is the value for tan pi by 6? This is 1 upon root 3. OB is equal to B, and this is equal to AE. That means 1 by root 3 is equal to B upon AE. Or E is equal to B upon A, root 3 B upon A. Also know one thing, that E square is equal to 1 minus B square upon A square. That makes E square is equal to 1 minus B square upon A square will be equal to E square upon 3. So this will be E square is equal to 1 minus B square upon this. So this is E square upon 3. Or you have 4 by 3. E square is equal to 1, which gives you E square is equal to 3 by 4. And what is the value for E square? This is A square minus B square upon A square. This is 3 by 4, which will give you 4A square minus 4B square is equal to 3A square. That means A square is equal to 4B square. Now,
ellipse also passes through 2 root 3, comma 1. See over here. It's given that ellipse also passes through this point. So that means 12 upon a square. I'm using x square upon a square plus y square upon b square is equal to 1. 12 upon a square plus 1 upon b square is equal to 1, which gives you 12b square plus a square is equal to a square b square, or 12b square plus 4b square is equal to 4b square, because we just solved over here that a square is equal to 4b square. So a square instead of that, I'm filling this, and yeah, it will be 4b square into b square. So this is 12b square, oh, sorry, 16b square is equal to 4b raised to power 4, or you have here 4b square is equal to b raised to power 4. Yeah, or simply you can say b square is equal to 4, correct? See, wait. I'll say b raised to power 4 minus 4b square is equal to 0. B square, I'm taking b square minus 4 is equal to 0. B cannot be equal to 0. Therefore, b square minus 4 is equal to 0, which makes b is equal to plus minus 2. Right? B square is equal to plus minus 2. Now we have to find out a square. A square, we already said that a square is equal to 4b square. So a square becomes 4 into b square was 4. That means this is 16. So a is equal to plus minus 4. Correct? What you need to find out in the question was the sum of length of major and minor axes. So you have to find out a plus b. So a plus b. Length of squares of that. So a square plus b square you need to find out. A square is 16 and b square is 4. So the answer to the question is sorry, I'm repeating this part. Length of the major axis is given by, this is not a square and b square. Length of major axis is actually 2a. So this is equal to 8 plus minus, and the length of minor axis is 2b. So this is equal to 2 into 2, which is equal to plus minus 4. So major axis length square plus minor axis length square is equal to this, which is 64 plus 16. That means 80 is the correct answer. So this 80 is the answer to the question. Option C is the correct answer. Hope you understood this. Let's move to the next question, number 57. If 4x plus 2y plus n is equal to 0 is normal to this ellipse, then what is the value for n? You're given the equation of the ellipse as x square upon 36, y square upon 16 is equal to 0. So here a square is equal to 36 and b square is equal to 16. So that gives you a is equal to plus minus 6 and b is plus minus 4. Now equation of normal to ellipse whose general equation is x square upon a square plus y square upon b square is equal to 1 is given by y is equal to mx plus c. Now if c square is equal to m square into this upon a square plus b square into m square. Okay. So here you are given the equation of the ellipse as this. And the normal is given to you as 4x plus 2y plus n is equal to 0, which gives you y is equal to minus 2x minus n by 2. Now on comparing these equations, you have already we said that a square is 36, b square is 16, and m is equal to minus 2 and c is equal to minus n by 2.
Now let's get back to our condition, which said c square. Wait, that was c square is equal to, should be equal to m square a square minus b square whole square upon a square plus b square m square. So now this is minus n by 2 square is equal to minus 2 square. A square was 36 and this is 16 whole square divided by 36 plus 16 m square. Directly writing this is 4. Okay, so this is n squared by 4 is equal to 4 into 20 into 20 whole divided by 36 plus 64, that is 100. Okay, so these two zeros will cancel and you will have n square is equal to 4 into 4 into 2 into 2, which will give you n is equal to plus minus 8. That's it. You needed a value of n, which is plus minus 8. That makes option D to be the correct answer. Hope you understood this. Next is question number 58. You are given y is equal to mx plus 4, where m is greater than 0. This is tangent to this hyperbola. Then the point of contact of this tangent is, fine, you're given, see, general equation, y is equal to mx plus c is tangent to the hyperbola, whose general equation is given by x square upon a square minus y square upon b square is equal to 1. Then in this case, their point of contact is minus a square m upon c minus b square upon c. So here in this question, a square is equal to 25 and b square is equal to 9. And in this case, m is equal to m and c is equal to 4. Therefore, their point of contact is given by, that was a minus a square m upon c minus b square upon c. So this is equal to minus 25 into m upon 4 comma minus 9 by 4. And the condition for tangent C is c square is equal to a square m square minus b square, or 16 is equal to 25 m square minus 9. That gives you 25 m square is equal to 25, which gives you m is equal to 1. Because you are given m is positive, I can't take the negative value for it. So therefore, their point of contact is minus 25 by 4 minus 9 by 4. So let's check. This is option A. This is the answer to the question. Let's move to the next question. Hope you are clear with this one. Question number 59. Let A be this point, B be this point, C be this point, are the vertices of the triangle ABC. If the internal bisector of triangle BAC meet the side BC at D, then what is the value for CD? What is the length for CD? You are given, this is a triangle. This is A, B, and C. So A is the point 3, 4, 3, 5, and B is the point 1, minus 2, 1. C is the point 3, 2, 1. These are the vertices of the triangle. Internal bisector of BAC meets side BC at D. So this is the one. You are given that this angle is equal to this angle. Okay, let's say this is side A and this is side B. Now, AD is bisector of angle A. Therefore, the ratio of BD and DC can be calculated. BD upon DC will be equal to AB upon AC. And this is equal to root of 3 square plus 5 square. I'm calculating the length for this. 3 square plus 5 square plus 4 square whole divided by root of 1 square plus 1 square plus 4 square, which is equal to 9 plus 25 plus 16 whole divided by root of 2 and this 18. Okay. Okay, this is a root of 50 upon 18. So 925. This is equal to 5 upon 3. So this is 5:3. That means D divides BC in ratio of 5:3. Hence, what does the D point become? This becomes 15 because see, this is the ratio of 5:3. So 5 into 3, 15, plus 3 into 1, 3. So this is 15 plus 3 divided by 5 plus 3, which is 8, comma 10 minus 6 upon 8, comma 5 plus 3 upon 8. That makes the D point as 18 upon 8, comma 4 upon 8, comma 1. You got this point. The C point was given to you as 3, 2, 1. And D point we just saw, this is 18. You can say this is 9/4, 1/2, and 1. So let's calculate CD. This is what you need to find out. So this is root of 9 upon 4 minus 3 whole square. 1/2 minus 2 square, 1 minus 1 square. That is 12. So this will be minus 3/4 whole square. This will be minus 3/2 whole square. Plus 0. This will be 9/16, 9/4. That is 16, 9 plus 36. So this is 45 upon 16. All right. So this is 3 into, no, this I can write it as 9 into 5 upon 16. So this is equal to 3 upon 4 root of 5. So this is the answer to the question. 3 upon 4 root 5. Option B is the correct answer. Hope you understood this. Next is question number 60. Let the direction cosines of the two lines satisfy this equation and this equation. Theta is the angle between these two lines. Then what is the value for cos theta? Right, you are given the two lines 3L plus 2M plus N is equal to 0 and 2 MN minus 3NL plus 5L M is equal to 0. Let's say this is equation 1 and 2. So from equation 1, what I get is N is equal to minus 3L plus 2M. Let's say this is equation 3. Now putting this in equation 2. You will get minus 2 minus 3L. Wait, sorry. Minus I've already considered. So this will be minus 2, 3L plus 2M plus 3L, 3L plus 2M plus 5LM is equal to 0. Minus 6LM minus 4M square plus 9L square plus 6LM plus 5LM is equal to 0. 9L square plus 5LM minus 4M square is equal to 0. Or you have a 9L square plus 9LM. I'm splitting the middle term. So this is it. 9L, L plus M minus 4M, L plus M is equal to 0. 9L minus 4M. Second one, L plus M is equal to 0. So you have two values. You have either L is equal to minus M or you have L is equal to 4M upon 9. Right? I hope you are clear till here. So next, when L is equal to minus M, then from equation 3, what we get is N is equal to minus 3M plus 2M, which is equal to M, minus L is equal to M is equal to N. That means L upon minus 1 is equal to M upon 1 is equal to N upon 1. Let's say this is equation 4. Now when L is equal to 4/9, see from here. When L is equal to 4 by 9 m, then N is equal to minus 4 by 3 m plus 2m. This is equal to minus 10 upon 3 m, or L upon 4 by 9 is equal to m is equal to n upon minus 10 upon 3, which makes L upon 4 is equal to m upon 9 is equal to n upon minus 30. Let's say this is equation 5 now. So now angle between, what you need to find in the question was angle between these two lines, then what is the value for cos theta? Now angle between lines whose direction cosines are proportional given in equation 4 and 5. So you have cos theta is equal to minus 1 into 4 plus 1 into 9, 1 into minus 30, whole divided by 1 plus 1 plus 1, 16, 81, 900. So this will be minus 4 plus 9 minus 30 root 3 root of that's got to be 997. Okay, so on solving this whole thing you will get minus 25 upon root of 2991. This is the answer to the question. Let's check with the options. You have this is the answer, cos theta. Okay. So I'm ignoring the C minus sign over here because it may lie in any of the quadrant. It may depend upon the quadrant in which theta is lying. Theta is the angle between the two lines, so we are ignorant about the quadrant in which it is. So probably it is 25 upon root of 2991, option C. Hope you understood that. Next is question number 61. If 1 minus 2, 1 is a point on the plane pi and pi is parallel to this plane, if the equation of pi is given by this, then what is the value for b minus 2c? Now, equation of, you are given this plane, right? This is the plane equation of plane parallel to this plane is given by x minus y minus z plus lambda is equal to 0. Now, let's say this is 1. Now, this plane passes through 1 minus 1, 1 minus 2, 1. Therefore, this is 1 plus 2 minus 1 plus lambda is equal to 0. That gives you value of lambda is equal to minus 2. Correct? We now equation of the plane becomes equation of the plane x minus y minus z minus 2 is equal to 0. Let's say this is equation 2. On comparing it with this equation, ax plus by plus cz minus 2 is equal to 0. You get that a is equal to 1, b is equal to minus 1, and c is equal to minus 1. Right? What you need to find out in the question was b minus 2c. So b minus 2c is minus 1 minus 2 into this, which is equal to minus 1 plus 2, that is equal to 1. So that's the answer to the question 1, but I don't have that. Instead, I have A's and what was the value for A? A was equal to 1, so this is equal to A. That makes option D to be the correct answer. Hope you got that. Next is question number 62. You are given this limit question, limit x approaching to plus greatest integer function x square minus x minus 2 plus limit x approaching 3 minus greatest integer function x square minus 4x plus 3 is equal to what? Okay. See, I'm just approaching this. So when you're having plus 2, this will be equal to, sorry, this is minus, right? This is minus 2 positive. So this will be equal to minus 2 square minus of minus 2 minus 2 plus, now this is minus 3 positive, correct? So this will be See, minus 3, negative. That means it will move on this side. On the left-hand side, it will be minus 4. Minus 3, and here is minus 4. So you will have minus 4 over here, minus 4 square, minus 4 into minus 4 plus 3. So simple as that. Now just this is equal to 4 plus 2 minus 2 plus 16 plus 16 plus 3, which is equal to 4 plus, this is 32 plus this, 35. So 39. This is option A. This is the answer. Hope you understood this. Let's move to the next question, number 63. Limit x approaching 0, this whole expression is equal to. All right, let's start it from here itself. I'll start solving. This is equal to limit x approaching 0, 3 raised to power 2x minus root of x plus 1 whole divided by x into sine 5x upon 5x into 5 into 2x square upon, I'm just writing down, I'll explain you this later like what I have done. Sine square 2x into 1 by 4. See now, I have this is 4, and over here I have introduced the 2x, which will be cancelled ultimately by here. And 1 minus cos 4x, this can be written as 2 sine square 2x. Right now, why I have done it over here is because I want to get sine 5x upon 5x thing, correct? And the rest you will just come to know. So here, this is, I'm taking this 5 upon 8 outside. Limit x approaching 0. This is like this. Limit x approaching 0. 3 raised to power 2x minus 1 upon x plus 1 minus root of x plus 1 upon x multiplied by limit x approaching 0 sine 5x upon 5x multiply limit x approaching 0 2x upon sine 2x square, right? I hope now the thing is clear, like why I have done all that. So this is equal to 5 by 8. That is equal to log e 3 raised to power 2 minus 1 by 2. Because if I'm putting this is equal to, yeah, so this is equal to minus 1 by 2. This is question number 63. Limit x approaching 0. This whole expression is equal to. I'll start the sum from here itself. Let's say this is equal to limit x approaching 0. Numerator is 3 raised to power 2x minus root of x plus 1 whole divided by. Okay. Let's keep it here only, and in the numerator I'm having sine 5x. So this is sine 5x upon 5x into 1 minus cos raised this. I'm going to write here 1 minus cos 4x can be written as 2 sine square 2x. So let's write it here 2 sine square 2x. So I'll do like 2x square. I'm going to write it over here. And for this 5, I will utilize it with this 5, correct? And yeah, and for this 4 that I've introduced, I'll divide it by 4 as well. And yeah, one more thing. If one x has been utilized over here and another one, I will write it over here. I think you're clear with what I've done. So this is equal to, I will take this 5 upon 4 into 2, 8 outside limit x approaching 0, 3 raised to power 2x minus 1 upon x. I can write this thing like this, plus 1 minus root x plus 1 upon x into limit x approaching 0 sine 5x upon 5x into limit x approaching 0 2x upon sine 2x whole square. This is equal to 5 upon 8 to log e 3 minus 1 by 2. Okay, this is 5 upon 16. I have taken the 2 outside, and this will be log e 3 raised to power 4 minus 1. So this is equal to 5 upon 16 log e 3 raised to power is 81 upon this can be 1 can be written as log e, so I will divide it with e over here. So this is the answer to the question, and here we have option B is the correct answer. Hope you understood that. Let's move to the next question. Question number 64. If fx is equal to modulus of x minus 1 plus modulus of x plus 2 minus 2, then what is the value for this expression? Fine. So here you are given the question fx is equal to x minus 1 plus x minus 2, the mod of both of them. So that means this fx have the two breaking points, that is 1 and 2. That means this is equal to, see, if I'm taking x less than 1, okay, if x is less than 1, then this has got to be minus x minus 1 minus x minus 2, which will be minus 2x plus 3. Sorry, this is minus 3. So this is minus 2x minus 3. And for x lying between 1 and 2. See, this has got to be, if this is lying between 1 and 2, so that means or if fx is equal to mod of x minus 1 plus mod of x minus 2, then what is the value for f dash this plus f dash this plus f dash this? You're given the function x fx is equal to x minus 1 mod plus x minus 2 mod. That means there are two breaking points, that is 1 and 2. So therefore, you will solve, you will get fx is equal to minus 2x plus 3 for x is less than 1. This will be equal to 1 when x lies between 1 and 2, and this will be 2x minus 3 when x will be greater than 2. Now, you have to find out the derivative. So let's find out the derivative at all these three breaking points. So this is equal to minus 2 for x less than 1. And this is equal to 0 for x lying between 1 and 2. And this is equal to 2 for x greater than 2. Now you have to find out f of minus f dash of minus 2023, which is of course less than 1. So that means this is equal to minus 2, and f dash 2024 upon 2023. This is greater than 1, but less than 2. So I'll take the value of this as 0. And the third one was f dash 2023, which is a positive value. So I'll take this as 2. So this is equal to 2. Let's add all of them. So you will get minus 2 plus 0 plus 4, which is equal to 0. So this is the answer to the question. Option C is the correct answer. Hope you understood this. Next is question number 65. So here you have fx is given by this. You have to find out the derivative at x is equal to 0. Let's find out the f dash x. This is given by denominator squared, which is e raised to power 3x plus e raised to power minus 3x whole square. Here you will have first of all the denominator e raised to power 3x plus e raised to power minus 3x into the derivative of the numerator, which is 2 into e raised to power 2x, and this is minus minus plus 2 into e raised to power minus 2x minus, here you will have then the numerator e raised to power 2x minus e raised to power minus 2x multiplied by e3 into e raised to power 3x minus 3 into e raised to power minus 3x. That is it. So you have to find out f dash 0. So let's just fill in the values for 0 instead of solving. This will be e raised to power 0 plus e raised to power 0. 2 into e raised to power 0 plus 2 into e raised to power 0 minus e raised to power 0 minus e raised to power 0. This is 3 into e raised to power 0 minus 3 into e raised to power 0. This whole is being divided by e raised to power 0 plus e raised to power 0 whole square. So this is equal to 2 into, this is 2 plus 2, 4. Minus this is going to cancel because anything raised to power 0 is equal to 1. So this will be 0 divided by 2 square. So the answer to the question is 2. That means you have option B as your answer. Hope you understood this. Let's move to the next question, number 66. If fx is given by x raised to power 10x plus tan x raised to power x, then what is the derivative of the function at pi by 4? You're given this function, let's say u is equal to x raised to power tangent of x and v is equal to tangent of x raised to power x. So that means the log of u will be equal to tangent of tangent x into log x. And let's find the derivative. You will have 1 upon u into the derivative of u with respect to x is equal to tangent x upon x. First function derivative of second plus second function into derivative of first, log x into secant square x. So, okay, let's get to this one now. Here you have done till here. So this is v is equal to tangent x raised to power x. Yeah. I'll just write it. Can I write it like this? Du upon dx is equal to u into tangent x upon x plus log x into secant square x, right? And here, filling the value for u was equal to x raised to power tangent of x. This is equal to, multiplied by tangent x upon x plus log x into secant square x. Okay. Now let's get back to our this one. We had here v is equal to tangent x raised to power x. Taking log on both sides, you have log v is equal to log v is equal to x into log of tangent x. Let's find out the derivative. So you have 1 upon v into dv by dx is equal to x into derivative of this. So this will be x into x upon tangent x into derivative of tangent x. This will be secant square x plus second function to derivative of first. So this will be log of tangent of x, right? That gives you dv by dx is equal to v into x secant square x upon tangent of x plus log of tangent of x. That gives you dv by dx is equal to tangent x raised to power x secant square x upon tangent x plus log tangent of x. All right, now you have to find out f dash. So f dash x will be equal to derivative of this plus derivative of this, and we took this as u and this as v. So f dash x will be equal to du upon dx plus dv upon dx. Let's write down the terms. This is equal to x raised to power tangent x multiply tangent x upon x plus secant square x into log of x plus tangent x raised to power x secant square x upon tangent x plus log of tangent of x, right? And now you have to find out this derivative at pi by 4. So that means f dash at pi by 4 is equal to pi by 4 raised to power tangent pi by 4, that is equal to 1. So I'll just remain it like this. Tangent pi by 4, this is 1 upon pi by 4, which can be written as 4 upon pi. Plus secant square pi by 4, this is also equal to 1 log of pi by 4. Here 2 will come here, right? Because see, secant square x is equal to 1 minus tangent square x Sorry, just a minute. Secant square x is equal to 1 plus tangent square x, and this is equal to tangent square pi by 4, this is 1, so this is equal to 2. So you will multiply it with 2 plus tangent pi by 4, this is 1 raised to power x, and it will be 1 only. And x was pi by 4, and the secant square x we just solved, it was 2 multiplied by 1 upon 1 plus log of 1, which is 0. Let's write it properly. You have here pi by 4, 4 by pi, plus this will be 2 log pi by 4 plus this will be pi by 2. That's it. Okay, so here you have a 2 plus pi by 2 log pi by 4 plus pi by 2. Right? I'm taking pi by 2 common here. So 1 plus pi by 2. Here you have log pi by 4, and this is 1, which can be written as 1 plus pi by 2 log pi by 4 plus log e. This is equal to 1 plus pi by 2 into log e into pi upon 4. This is the answer to the question. And you have, here it is, option A is the correct answer. Hope you understood this. Let's move to the next question, number 67. The nearest approximate value of under the root 2023 is. All right, so let's say y is equal to root of x. That means dy by dx is equal to 1 upon 2 root x, which is giving you equal to 1936. Because if I'm taking 2023, this lies between two perfect square, that is 1936, which is 44 square, and 2025, which is 45 square. So I'm going to take the lesser value, that is 1936, because it definitely is going to be less than 2025. Correct. So that means in this question over here till now, x is equal to 1936. So that means the change in x, the difference in x is equal to, this has got to be 87, right? And delta y is equal to given by root of x plus delta x whole under the root minus root of x. That means delta y is equal to root of 2023, because this is equal to x plus delta x is equal to 2023, for which we have to find out the root, minus 1396 under the root. That is delta y plus this is equal to 44. So I'm taking on the LHS, plus 44 is equal to root of 2023. Therefore, the approximate value of root of 2023 is delta y is equal to dy by dx into delta x, which is equal to this. And this is equal to delta x, this was, sorry, root of x was this, into delta x is 87. So 1 upon 2 into 44 into 87. That gives you 87 upon 88, which is approximately 0.9778. So now let's get back to our equation. We had root of 2023 is equal to 44 plus delta y. So this is equal to 44 plus 0.9778. That is equal to 44.9778. This is the answer to the question. Now let's check. You have option B as the answer. Hope you understood this. Next is question number 68. The slope of the normal drawn at the point P to this curve is minus 1 by 14. If the coordinates of P are integers, then the x-intercept of the tangent drawn at P to the given curve is. Fine. You are given the curve. Y is equal to x cube minus 10x square, 31x minus 30. Let's find out the derivative. So dy by dx is equal to 3x squared minus 20x plus 31. This is the slope of the curve, and the slope of the normal, the product of both of them is equal to -1. So slope of the normal will be equal to -1 divided by dy by dx. So this is equal to, and this is given in the question that this is equal to -1 by 14. That gives you dx upon, yeah, dx upon dy is equal to 1 by 14, or dy by dx is equal to 14. That means this is equal to 14. Let's go. 3x squared minus 20x plus 31 is equal to 14. 3x squared minus 20x minus 17 plus 17 is equal to 0. Let's split the middle term. 3x squared minus 3x minus 17x plus 17 is equal to 0. So 3x minus 3x x minus 1, and I'm taking minus x. So sorry for this. I'm going to write. So 3x has been taken common. X minus 1 minus 17, x minus 1 is equal to 0. 3x minus 17, x minus 1 is equal to 0. That gives the value of x is equal to 1, or 17 by 3. Now the coordinates, you are given the coordinates are integers, so I can't take this value. That means x is equal to 1. And for x is equal to 1, you will have the y, which was equal to x cubed minus 10x squared plus 31 x minus 30. For x is equal to 1, this is 1 cube minus 10 into 1 square plus 31 minus 30, which is equal to minus 8. So the coordinates of P are 1, comma, minus 8. Now, slope of the tangent, slope of tangent at P is given by dy by dx at this point, 1 comma minus 8. This was the slope equation was 3x squared minus 20x plus 31. So this will be 3 minus 20 plus 31. So this is equal to 14. This is the slope, right? So equation will be equation of tangent, you know that formula, y minus y1 mx minus x1. So this is the point and this is the slope. Let's fill. You have 5 minus of minus this will be minus of minus 8 will be plus 8 is equal to 14 x minus 1. So you have 14x minus y minus 22 is equal to 0, or you can write it as x upon 11 by 7 plus y upon 22 is equal to 1. So you had to find out the x-intercept, which is this one. So that is equal to 11 upon 7. This is the answer to the question. Option C is the correct answer. Hope you understood this. Next is question number 69. So you are given x and y are two positive integers such that 2x plus 3y is equal to 50, and x square y cube is maximum for x is equal to alpha and y is equal to beta. Then alpha upon 2 plus beta upon 5 is equal to. Okay, so fine. You're given this equation and you're given if x square y cube is maximum for x is equal to alpha and y is equal to beta. Let's say this is equal to z. Z is equal to x square y cube, and from here x is equal to from here I'm calculating 2x. Wait, I'm going to rewrite. You have z is equal to x square y cube, and you have 2x plus 3y is equal to 50. From here you will get 2x is equal to 50 minus 3y, or x is equal to 50 minus 3y upon 2. Right? And see, let's fill in this value of z in z. So you have z is equal to 50 minus 3y upon 2 square into y cube. So let's solve it. Z will be equal to 2500. I'm opening like this will be y cube will be multiplied plus 9y raised to power 4 minus 300 y raised to power, sorry, y raised to power 5 minus 300 y raised to power 4. upon 4. Now for the maximum or minimum values, dz upon dy should be equal to 0. So that means you have, let's find out dz upon dy first of all. So this is equal to 1 by 4. We'll come over here. This will be 7500 y square plus 45 y raised to power 4 minus 1200 y raised to power 3. Now, this is equal to 0. So that means 7500 y square, I'm taking y square common. All right. So 7500 plus 45 y square minus 1200 y is equal to 0. Now they are positive integers. So this is greater than 0. That means 3y square. I'm dividing both sides by 15. So 3y square minus 80y plus 500 is equal to 0. Let's split the middle term. So the two factors will be 3y square. One will be, you have own 1500, right? So 50 and 30. So minus 50 minus 30y plus 500 is equal to 0. Or you can say this is 3y square minus 30y minus 50y plus 500 is equal to 0. 3y minus 30y. Okay, no, okay. So this is minus 50y minus 10 is equal to 0. So two factors, 3y minus 50 and y minus 10 is equal to 0. So y is integer. Therefore, the two possible values are y may be 10 or 50 upon 3. I will not take 50 upon 3 because y is an integer. So that means here x is equal to 10 and y is also equal to 10. Now you are given x square and y cube. This is maximum at x is equal to alpha and y is equal to beta, which will be 10 in each case. So to find in the question was, it was alpha upon 2, beta upon 5, alpha upon 2 plus beta upon 5, 10 upon 2 plus 10 upon 5. This will give you 7. So this is the answer to the question. Option D is the correct answer. Hope you understood this. Next is question number 70. Integral of 1 upon 16 minus this is equal to. Okay, let's do one thing. Let's divide the numerator and the denominator by cos square x. So you will have integral of secant square x divided by 16 secant square x minus 7 tangent square x dx. This is equal to secant square x 16 1 plus tangent square x minus 7 tangent square x dx. That is secant square x upon 16 plus 16 minus 7. This will give you plus 9 tangent square x dx. Now let's put tangent x is equal to t. So derivative secant square x dx is equal to dt. That gives this now to be I. Let's say this is equal to I. So I is equal to dt upon 4 square plus 3t square. It is of this form, correct? So one thing, you have a formula that is the integral of dx upon x square plus a square is equal to 1 upon a tangent inverse x upon a. So I'm going to use this thing only over here. What is a in this case? 4. So this is 1 by 4 into tangent inverse 3t upon 4 multiply 1 by 3. So this will be 1 tangent 1 upon 12 tangent inverse. Now t was equal to tangent of x. So this is the answer. Right, plus the constant c when I opened up this integral. Right, this is the answer to the question. Let's check with the options now. So I think yes, it is option A. Right. Hope you understood this. Next question number 71. Again, an integral problem. So now secant square upon secant x plus tangent x whole square. Let's do one thing. Let's put secant x plus tangent x is equal to t. That means if this is equal to t, you know one thing, that secant square x minus tangent square x is equal to 1. So that means if this is equal to t, then what will be secant x minus tangent x? This will be equal to 1 upon t. How did you get this? Because this can be written as secant x plus tangent x into secant x minus tangent x is equal to 1. If this is equal to t, so secant x minus tangent x will be equal to 1 upon t. All right. Now, let's find out the derivative. Secant x tangent x plus secant square x dx is equal to dt. I'm taking the secant x common from here, so you will have secant x plus tangent x dx is equal to dt. Right, this was equal to a t. So you have here secant x into t into dx is equal to dt, or secant x dx is equal to 1 upon t into dt. Right? Okay. So one more thing. T is equal to secant x plus tangent x, and 1 upon t is equal to secant x minus tangent x. That means t plus 1 upon t is equal to secant x, or secant x is equal to 1 upon 2 into t plus 1 upon t. So that means this is equal to t upon t plus 1 upon t whole divided by 2 is equal to 1 upon t into dt. Okay. So now let's get back to our question over here. We have to solve this. Let's get back. Let's say this was I. So I is equal to, let's write it once. You had secant square x upon secant x plus tangent x dx, right? Okay. So this can be written as a 1 by 2. I'll first of all split. This will be equal to integral of secant x upon secant, here was whole square, secant x plus tangent x square into secant x dx. So this is equal to secant x is equal to this. I'll write down 1 upon 2 t plus 1 upon t, and this is equal to t. So this is equal to t square. Secant x dx was equal to 1 upon t into dt. Let's write that 1 upon t into dt. So this makes it 1 by 2 integral of 1 upon t square plus 1 upon t raised to power 4 dt. So this is equal to 1 by 2 t raised to power minus 2 plus 1 upon minus 2 plus 1 plus t raised to power minus 4 plus 1 upon minus 4 plus 1 whole plus c. So this is equal to 1 by 2, 1 minus 1 upon t minus, that's yeah, just wait. I'll rewrite this 1 upon t raised to power minus 1 upon minus 1 plus t raised to power minus 3 upon minus 3 upon 2. So this is equal to 1 upon 2 minus 1 upon t minus 1 upon 3 t cube plus c. So this is, let's open up. This will be equal to minus 1 by 6, 3t square plus 1 upon t cube plus c. Now let's fill in the value for the t. Minus 1 by 6, 1 plus 3 secant x plus tangent x whole square divided by secant x plus tangent x whole cube plus c. Right. This is the answer to the question. Let's check. You have this is the option C, B, sorry. option B is the correct answer to the question. Hope you understood this. Next is question number 72. So integral of this whole expression is equal to, let's say this is equal to I. And one thing, cos x is equal to 1 minus tangent square x by 2 upon 1 plus tangent square x by 2, because all the answers, all the options are in tangent. So I have to take the cos and the sin x in terms of tangent, and sin x is equal to 2 tangent x by 2, upon 1 plus tangent square x by 2. So this integral becomes 1 integral of 1 upon 3 into 1 minus tangent square x 1 plus tangent square x minus 4 into 2 tangent x by 2 upon 1 plus tangent square x by 2 and plus 5, right? This is the one that this is equal to integral of 1 plus tangent square x by 2 whole divided by 3 minus 3 tangent square x by 2 minus 8 tangent x by 2 plus 5 tangent square x by 2 dx. This is equal to integral of secant square x by 2 whole divided by 2 tangent square x by 2 minus 8 tangent x by 2 plus 8. Now let's put tan of x by 2 is equal to t. This gives you secant square x by 2 into dx is equal to, this will be multiplied by like 1 by 2 because x by 2 derivative will be 1 by 2. This is equal to dt, or secant square x by 2 dx will be equal to 2 dt. Now this integral, the above integral, it will become 2 dt whole divided by 2t square minus 8t plus 8. This is equal to integral. I'm dividing numerator and denominator by 2. So t square minus 4t plus 4. Now this is equal to what dt upon t minus 2 square, and this is equal to integral of t minus 2 raised to power minus 2 into dt. So this is, let's find out the integral. This will be t minus 2 raised to power minus 2 plus 1. This is minus 1 upon minus 2 plus 1, which is minus 1 plus t. So that makes it 1 upon minus 1 upon, wait, this is equal to 1 upon t minus 2, right? Minus outside plus t. So this is equal to this. 1 upon 2 minus t. And what was t? Let's fill in the value. It was equal to tangent of x by 2 plus c. So this is the answer to the question. Let's check with the options. You have, here it is. Option C is the correct answer. Hope you got that. Let's move to the next question. Question number 73. Integral of this expression is equal to, again, let's say this is equal to I, and 1 upon, let's solve this for first, x minus 2 into x square plus 1. This can be written as a upon x minus 2 plus bx plus c upon x square plus 1. So you have 1 is equal to a into x square plus 1 plus bx plus c into x minus 2. So 1 is equal to a x square plus a plus b x square minus 2bx plus c x minus 2c. I'm taking the a plus b common, x square and plus x, you have c minus 2v plus a minus 2c. This is equal to 1. So on comparing the coefficients of x square, x, and the constant, comparing coefficients of x square, x, and constants, you have a plus b is equal to 0, minus 2b plus c is equal to 0, and a minus 2c is equal to 0, which gives you a is equal to 2c. Okay, a is equal to 2c, so that means 2c plus b is equal to 0. And from here, if I multiply this with 2 and mm, I'll do one thing. I will not multiply this with 2. This is equal to 0. I'll multiply this with 2 and add over here. So this will be 2b plus 4c is equal to 0, which gives you c is equal to 5c is equal to, sorry, I did a mistake. Here was 1. So sorry for this. This is 1 because a minus 2c, this is equal to the constant. This is equal to 1. So I'll rewrite these equations. You have a plus b is equal to 0 minus 2b plus c is equal to 0 and a minus 2c is equal to 1. So this gives you a is equal to minus b. Okay, that makes here 2a plus c is equal to 0 and let's do this thing. Let's multiply it with 2 and add over here. So you have 4a plus 2c is equal to 0, which makes 5a is equal to 1 or a is equal to 1 by 5. If a is equal to 1 by 5, b will be equal to minus 1 by 5, correct? And on solving, you will get the value of c as minus 2 by 5. So let's write down the values once again. You have a as 1 by 5, b as minus 1 by 5, and c as minus 2 by 5. Now the integral becomes I is equal to 1 by 5 will be taken outside, integral dx upon x minus 2 minus 1 by 5 integral x upon x squared plus 1 dx minus 2 upon 5 dx upon x squared plus 1, which gives you this is equal to 1 upon 5 log of x minus 2 minus 1 by 5 log of root of x squared plus 1 minus 2 by 5 tangent inverse x plus c. This is equal to 1 by 5 log mod of x minus 2 divided by this minus 2. I'm taking 1 by 5 common, tangent inverse x plus c. So let's check out with the options which is the correct answer. Here you have option D is the correct answer. Hope you understood this. Next is question number 74. So again, an integral problem, you have to find out the integral of this. So pretty easy. Only the problem is you have a modulus over here. So that means it will be divided into 3 parts. So first is x square minus 3x plus 2. This will be equal to x squared minus 3x plus 2 for x lying between 0 and 1. And this will be minus x squared minus 3x plus 2 when x is lying between 1 and 2. And this will be positive this when x is between 2 and 3. Okay. Now let's get back over here. It will be broken up into 3 intervals. This will be, let's say this is equal to I. So I will be broken up into 3 intervals, which is first is 0 to 1. X square minus 3x plus 2 dx minus 1 to 2. X squared minus 3x plus 2 dx. And the plus limit 2 to 3. X squared minus 3x plus 2 dx. Okay. Let's find out the integral now. This will be equal to x cube upon 3 minus 3x squared upon 2 plus 2x 0 to 1 minus x cube upon 3, 3x squared upon 2 plus 2x 1 to 2 plus x cube upon 3 minus 3x upon 2 plus 2x limit 2 to 3. Okay, here was 3x squared. All right, so let's fill in the values now. Let's put the limits. You will have 1 by 3 minus this will be 3 by 2 plus 2 minus 8 by 3 minus 12 by 2 plus 4 plus 1 by 3 minus 3 by 2 plus 2 plus 27 upon 3, 27 upon 2 plus 6 minus 8 upon 3, 12 upon 2 plus 4. So on solving this whole thing, you will evaluate that the answer comes out to be 11 upon 6. This is the answer. That means option A is the correct answer. Hope you understood that. Let's move to the next question. Question number 75. Integral of, these are the limits, minus pi upon 8092 to pi upon 8092. This expression is equal to, let's say this is equal to I. So this is equal to, one thing, before starting with this, I would like to discuss a formula. Let's say this is equal to I. And the formula is that the limits are from A to B, f of x dx. This can be written as limits A to B, f of A plus B minus x dx. So now this integral, this becomes, this I is equal to limits minus pi upon 8092 to pi upon 8092. This is equal to 2023 raised to power 2023 x secant 2023 x. Question number 75. So you have to find the integral. The limits are given minus pi upon 8092 up to till pi upon 8092. This whole expression is equal to. Let's say this is equal to I. Before starting with the question, I would like to discuss one formula. If you are given the limits a to b, fx dx can be written as limits a to b, f of a plus b minus x dx. Using that, I will rewrite this as I is equal to integral minus pi upon 8096 2 pi upon 8096 secant minus, secant, I'm adding both of them, this plus this will come out to be 0 minus 2023x whole divided by 1 plus 2023 raised to power. Again, same thing, when I'll add them, you'll have 0, but here will be minus 2023 x dx. This is equal to limit minus this to this 8096. Secant minus 2023x can be written as, because cos of minus x is equal to cos x. So similar is the case with secant. So this is equal to secant 2023x dx whole divided by, this will be 1 plus 1 upon 2023 raised to power 2023x, because 2023 1 upon 2 raised to power minus x can be written as 1 upon 2 raised to power x. So this can be written as this. Now this will be equal to integral limit 0 this to this. This will go in the numerator. I'm taking the LCM into secant 2023x whole divided by 2023 raised to power 2023x plus 1 dx, correct? So let's say this is equal to 2 and this is equal to, wait, now this is, let's say this is 1, adding 1 and 2, adding 1 and 2. You will have a 2I is equal to integral minus pi upon 8096 to pi upon 8096. You will have a secant 2023x plus, it was 2023 raised to power 2023x into secant 2023x whole divided by 1 plus 2023 raised to power 2023x dx. So you have 2I is equal to minus pi upon this, 2 pi upon this. I'm taking secant common.
secant this common. So you will have 1 plus 2023 raised to power 2023 x whole divided by 1 plus 2023 raised to power 2023 x dx. These two will cancel and you will have 2I as this. So you have secant 2023 x dx. Right, let's find out the integral. Also, one more thing, if I divide it with 2, this is equal to I is equal to 1 by 2. Now, this can be multiplied like 2. I'm saying this is an even function, so you can write it as 0 to pi upon this secant 2023 x dx. Now, this is equal to 2 and 2 will cancel. So the integral of this is equal to log secant 2023 x plus tangent 2023 x. Yeah, whole divided by 2023 plus the constant c. Limits from 0 to pi upon 8096. So let's put the limits. This is log secant pi upon 4 plus tangent pi upon 4 whole divided by 2023 plus c. This is log root 2 plus 1 upon this plus c. So this is answer to the question. And let's see, you have option B as your answer. Hope you got that. Next is question number 76. Integral limit 0 to 2 x raised to power 5 by 2 root of 2 minus x dx is equal to. Let's say in the question, let's say x is equal to 2 sine square theta. So dx will be equal to 4 sine theta cos theta d theta. Now at x is equal to 0, you have theta is equal to 0 and x is equal to 2. Theta will be pi by 2. Therefore, this integral, if I say this is I, therefore this integral becomes I is limits will change 0 to pi by 2. 2 sine square theta raised to power 5 by 2. 2 minus 2 sine square theta into 4 sine theta cos theta d theta. So this is 0 to pi by 2, 2 raised to power 5 by 2, sine raised to power 5 theta into 2 raised to power 1 by 2, cos theta 4 sine theta cos theta d theta. This will be equal to 32, limits 0 to pi by 2 sine 6 theta cos square theta d theta. Now to solve further, I'll be using Bayes' formula. Using Bayes' formula, you have 0 to pi by 2, which is mx cos nx dx is equal to m minus 1, m minus 3, m minus 5, so on into n minus 1, n minus 3, so on, whole divided by m plus n minus 2, so on till k. This is multiplied by k. So here k is equal to pi by 2 when m n are even, and this is equal to 1 when not. So let's get back to our question. That integral was equal to here m is equal to 6 and n is equal to 2. M is equal to 6, n was equal to 2. So that integral is equal to, first of all, 32 was outside. So 32 into 5 3, 1 into 1 whole divided by 8, 6, 4, 2. Because m and n are even, so this is multiplied by pi by 2. So this, solving this whole will give you 5 pi by 2. This is the answer to the question. And 5 pi by 2 was, we'd have done some 2 and 4, 8, 16, 2. So this is, wait. This is 2 and this is 8. 8 to the 16. This will cancel at 2. Yeah, this is also there. So this will cancel with this. Okay. So this will be 5 pi by 8, not 2, sorry. That means you have option C as your answer. Correct. Next is question number 77. Area of the region bounded by this curve, x-axis, y-axis, and the line this is given by. See, to always answer such type of questions, it's best thing to draw the figure. This is the x-axis and the y-axis. So let's say this is the curve. So this is the axis. X-axis and the line x is equal to -2. Let's say this is the line x is equal to -2. And this is your x-axis.
Question number 77, area of the region bounded by this curve, x-axis, y-axis, and the line x is equal to -2 is given by. Okay, so first of all, this is the equation of the curve, and if I plot the points, then for x is equal to 0, y will be 2, for x is equal to 1, y will be -2, for x is equal to -1, y will be 0, and for x is equal to 2, it will be -12, -2, it will be -16. One more thing, if I'm putting y is equal to 0, so this equation 3x square plus x minus 2 is equal to 0. So the two factors for this equation will be 3x square plus 3x minus 2x minus 2 is equal to 0. 3x, x plus 1 minus 2, x plus 1. So the two factors will be 3x minus 2, x plus 1 is equal to 0. You will have x is equal to -1 or it is 2 by 3. So that means this curve is cutting the x-axis at 2 points, -1 and 2, 3. Let's make it over here. So this is the curve. This is 1, 2, -1, -2. So for first of all, this is the line, x is equal to -2. And it is cutting the graph at -16. So this is the graph. And this is for -1, this is 0, this is the point. And for 0, it is at 2, so over here. And for for 1, it is -2, so that means this point is over here. And it is also 0 for 2 by 3, so about over here, this is another point. And for x is equal to 2, it is -12. So about approximately the graph looks somewhat like this. It's not an exact one, but approximately the graph is going to look something like this. Okay, so this is the point 2, -12. And this is the point 0, 2. This is the point 2 by 3, 0. And this one is -1, 0. All right. So you want to find out this area of the shaded region, this one. Okay, so the two breaking points from here to here, first of all, this is -2 to -1, and then -1 till 2 by 3. So that means required area is equal to integral of 2 minus x minus 3x square dx from -2 to -1 plus -1 till 2 by 3 to minus x minus 3x square dx. Let's go for this. So this integral will be 2x minus x square upon 2 minus 3x cube upon 3, which will be x cube, limits -2 to -1 plus -1 till 2 by 3. So this is 2x minus x square upon 2 minus x cube. All right, so let's fill in the values. Now you have to be patient because you might do some mistake. This is minus 2 minus 1 by 2 plus 1 minus 4 minus 2 plus 8 plus, see, remember this is I'm finding the area, so mod will be taken over here. Okay, so this is 4 by 3 because the limits are this. So 4 by 3 minus 2 by 3 minus 8 by 27 minus of minus 2 minus 1 by 2 plus 1. Okay, more of it. So this is equal to minus 1 minus this. So this is minus 3 by 2 minus 2 plus you have here 2 by 3 minus 8 by 27 and this one will be plus 3 by 2. Okay, these two will cancel out and you have my mod of minus 2 plus 2 by 3 minus 8 upon 27. So I'm taking 27 as the LCM and here you have minus 54 plus 18 minus 8. So minus 54 mod of it. So the answer to the question is 44 by 27. That's it. You have option B as your answer. Hope you understood this. Let's move to the next question, number 78. If A and B are arbitrary constants, then the differential equation this as its general solution is which of these options? So here we have y is equal to a e raised to power x plus b sine 2x. This equation, let's find a differential equation of it. So dy by dx will be equal to a e raised to power x plus 2b cos 2x. Let's find the second derivative. So this is e raised to power x minus 4b sine 2x. So let's, if you will, minus 4b sine 2x. So on substituting these values in option A, you will get the LHS as cos 2x minus sine 2x a e raised to power x minus 4b sine 2x plus 4 sine 2x a e raised to power x plus 2b cos 2x minus 4 sine 2x cos 2x a e raised to power x plus b sine 2x. That gives you a e raised to power x cos 2x minus 4b sine 2x cos 2x minus a e raised to power x sine 2x. Yeah, plus 4b sine square 2x plus 4a e raised to power x sine 2x 8b sine 2x cos 2x 4a e raised to power x sine 2x minus 4b sine square 2x minus 4a e raised to power x cos 2x minus 4b sine 2x cos 2x. Now this is not equal to 0 and similarly check with other options. No other option is also satisfying the given equation. So that means none of these is the answer. Hope you got this. Next is question number 79. The general solution of the differential equation, this is which of these options? All right, so let's write down the equation first. Here you have dy by dx is equal to sine x minus y plus cos x minus y. Let's put this as v. So you will have a, let's find differentiate both the sides with respect to x. So 1 minus dy by dx is equal to dv by dx. That means dy by dx is equal to 1 minus dv by dx, or you have 1 minus dv by dx. What was dy by dx? That was equal to this. So 1 minus dv by dx is equal to sine x minus y, that is sine v cos v. Or you have 1 minus sine v minus, sorry, here was plus. So cos v is equal to dv by dx, or dx is equal to dv upon this dx is equal to, I'll break it up now, dv upon 1 minus, this can be written as 2 tan v by 2 upon 1 plus tan square v by 2 minus 1 minus tan square v by 2 upon 1 plus tan square v by 2. So that means dx is equal to secant square v by 2 dv whole divided by 1 plus, I'm taking the LCM and taking the denominator on the upper side, okay? 1 plus tan square v by 2 minus 2 tangent v by 2 minus 1 plus tangent square v by 2. That makes dv is equal to secant square v by 2 dv whole divided by 1 will cancel, and you will have 2 tangent square v by 2 minus 2 tangent v by 2. Now it's integrate on both the sides now. You will have x is equal to, also I'll do one thing before solving. Let's put tangent v by t, 2 is equal to t. That will give you secant square v by 2 dv is equal to 2 dt, because this half I'm taking on the right hand side. So you will have here, let's now integrate. You will have, after integrating, you will have x plus c is equal to integral of dt upon t into t minus 1, which is equal to integral of minus 1 upon t plus 1 upon t minus 1 dt. On solving, this will be equal to log of mod of t minus 1 minus log of t, which is equal to log of t minus 1 upon t. Let's fill the value for t now. So you have x plus c is equal to log of tangent v by 2 minus 1 upon tangent v by 2. That means x plus c. Now let's fill the value for v as well. Tangent of x minus y upon 2 minus 1 upon tangent of x minus y upon 2. So this is the answer to the question, and you have option, yeah, this is the answer. Option B is the correct answer. Hope you understood this. Now let's move to the next question. Number 80. This is going to be the last question for this paper. So let's go with that. The general solution for this differential equation is, right, let's write down the equation. You have x squared dy minus xy minus y squared dx is equal to 0. Okay, the general solution of this differential equation is this, sorry, this is rewritten. I'll start solving it again. So this is the general equation, x squared dy minus xy minus y squared dx is equal to 0. So that means dy by dx, that can be written as xy minus y square upon x square. Now let's put y is equal to vx. So you will have dy by dx is equal to v plus x into dv upon dx, or v plus x into dv upon dx is equal to x square v minus x square v square divided by x square, or x into dv by dx is equal to v minus v square minus v. That means you have x into dv upon dx is equal to minus of v square. Okay, so next dx upon x will be equal to minus 1 upon v square dv. That means I'm integrating on both the sides. So you will have log of x is equal to 1 by v plus c, or log of x is equal to 1 by v, that is equal to x upon y plus c, or you can say y log x is equal to x plus c y. This is the answer to the question. Let's check. Option C is the correct answer. So students, with this, we have completed all the 80 questions of this paper. Hope you understood them well. A very best of luck for your exams, and don't forget to visit our website www.examsnet.com for a better preparation of your exams. Here you will find detailed PDF solutions of all the entrance exam question papers. You must download our app for a better preparation of your examinations. A very best of luck. That's all for this paper. Keep shining, keep rising high. Bye.